Hi everyone, good morning. A very warm welcome to the second day of the 5th edition of ACE 2024. Today we begin with the thematic session 4, which is Decarbonizing India's Building Sector, Research Goals for the Future. Before we start, a few housekeeping rules. If I could request you to please keep your phones on the silent mode. We have tea and coffee arranged outside. You have in front of you some QR codes which can be scanned to access and download the agenda as well as description for the session. Coming back to session 4, today we look at how decarbonization of India's building sector is going to play a leading role in India's energy transition. India has set an ambitious target to achieve a net zero economy by 2070. This demands all sectors to align their development strategies towards the goal. As India's building and construction sector is growing at a rapid pace, the demand for essential construction materials like steel, cement, aluminium and others is expected to increase multifold. Buildings consume a third of India's total electricity production in 2023-24. And as per some data, the building sector contribution to India's total GHG emissions in 2020 was estimated at approximately 26%. To achieve decarbonization goals, strategies must address embodied operational and end-of-life carbon from buildings. This session will invite organizations to deliberate on key gaps in current research on reducing carbon across the whole building life cycle in India. Today for this discussion, we have a few facilitators, if I may invite them. Sumedha Malviya, Deepak Tiwari, Shiny Sam, and Dylan Subramaniam from WRI-India, and Feroz Lutfi from WRI Mexico. Some of our key discussants for this panel are Dr. Sukhdev Karade, Chief Scientist, Central Building Research Institute, Roorkee; Saswati Chetia, Director, Green Tech Knowledge Solutions Private Limited; Dr. Somin Mehti, Chief Technology Officer, Development Alternatives; Rajneesh Sareen, Program Director, Center for Science and Environment; Tarun Garg, Principal, RMI India Foundation; Mohak Gupta, Associate Program Director, Circular Economy and Resource Efficiency, Development Alternatives; Soumya Garnayak, Country Representative, Global Green Growth Institute; Pratima Vashan, Senior Expert, Alliance for Energy Efficient Economy; Ashu Dehadani, Director, Technical Development, Green Business Certification; Shiv Kumar Batra, Global Product Management Specialist, Career Corporation; Dr. Ankita Gangotra, Cement and Steel Lead, Industrial Decarbonization and Carbon Removal, WRI USA; Abhishek Chauhan, Senior Manager, Cooling Solutions, Smart Joules.
Thanks, Niharika. So, a few changes in our lineup actually. Dr. Somin Mehti from Development Alternatives is under the weather, so he's not here. And instead of Tarun, we actually have Akhil, and he's over there. Great. So we can get started. We wanted to use this opportunity to set the context a little on why we're talking about building decarbonization. And of course, I mean, people in the audience and our speakers here are already familiar with some of the data that is presented on the slide. With respect to the energy consumption growing in the building sector, it currently accounts for 30% of total electricity consumption. But with the rising cooling demand, we are expecting an additional 800 gigawatts of power generation capacity to just meet cooling needs by 2050. The sector also contributes significantly to GHG emissions, and these are both the direct and the indirect emissions. Direct ones from the electricity consumption in the buildings itself, and the indirect ones from the production of materials, construction materials particularly. So the split is around 14% from operations and 12% from production and use of building materials. And with rapid urbanization, we are going to see more and more of not just the energy consumption, but a doubling of just the demand for cement and a tripling of steel demand by 2040. With this floor era being added about close to about 60 billion square feet of built floor area to be added by 2050. But at the same time, the sector also represents quite a few opportunities when it comes to accelerating India's energy transition. There is a role energy efficient buildings can play in not just meeting the same amount of energy services in less energy, therefore mitigating the need for more investments in clean energy, but also building resilience of our buildings to climate change and ensuring thermal comfort for all. There are opportunities in sector coupling when you integrate decentralized renewables and RE-based electrification of end users in buildings to further reduce our dependence on fossil fuel-based energy services. And of course, there is also the element of digitalization, where we are using smart technologies, digital technologies to create buildings which are more flexible and more adaptable and integrated to our energy grids. In the context of looking at it from a whole life cycle perspective, and this is just to give the audience a sense of which aspects of the building life cycle we are talking about, just sort of describing some of the key terms that we would be using today during our discussion, because our discussions are going to be divided into two rounds. The first round, where we'll be talking about embodied carbon and end-of-life carbon, because of the interlinkages between these two aspects, and lastly, the operational carbon. So as some of you already know, when we're talking about embodied carbon, we are referring to emissions which are specifically released during the extraction of raw materials, which are inputs to the building materials that we use today. When operational carbon is something which many of us are already familiar with, which is the carbon related to the energy used in operating our buildings, in services, equipment and appliances. And the end-of-life carbon, because buildings are not just shells which do not have any value at the end of life, it refers to the carbon which is embodied in all the materials that were there, and once they reach end of life, you have emissions associated with the deconstruction or demolition of building, including how they are transported, processed, recycled, etc. at the end of life stage. So those are the three types of carbon we would be talking about in our discussion today. And interestingly, in the last couple of years, the knowledge in this space has been enhanced by civil society, by researchers working on building decarbonization. Just going to share a few snapshots from recent studies conducted on the whole life cycle carbon. So these are projections from a recent study that CSTEP did, wherein they looked at modeling the different pathways to decarbonizing buildings, looking at scenarios of business as usual, decent living standards, building-led strategies and industry-led strategies. Building-led strategies referring to strategies which will come from the building sector, essentially policies and regulations to promote passive design, energy efficiency, integration of solar PV, and the industry-led strategies, because as we spoke about the contribution of materials like cement and steel to building decarbonization, how do new alternative fuels in these sectors like cement, steel and aluminum, shifts in processes and manufacturing industries can lead to this sort of decarbonization pathway. The black line, as you can see, refers to the sort of the decent living standard scenario, wherein if we continue to provide the right kind of comfort and resilience to communities, then that's the pathway we are looking at as far as GHG emissions is concerned. And the green one refers to the combination of building-led sectoral strategies and industry-led strategies. So these are interesting projections which have come out from CSTEP, and before that RMI had done a good amount of work on developing basically a roadmap for building decarbonization at the national level, and they had identified and stacked these technical interventions which would be needed to achieve decarbonization by 2050. And as you can see, majority of the embodied carbon reductions are going to come from design stage interventions, followed by the selection of low carbon materials. As far as operational carbon is concerned, majority of them will come from passive design strategies, meeting energy needs through efficient equipment in residential buildings. And lastly, centralized renewable energy is also a component of this, but it's going to not meet all the emission reductions that we need. So typically the electrification of grid and its electrification of end users, which is currently happening, even if it continues to be supported by renewable energy, that itself will not be sufficient for decarbonizing the entire building sector. So these are findings from the RMI analysis, and this was with respect to the embodied carbon and operational carbon discussion. But there are also some recent studies which have come looking at the split of how does embodied carbon and operational carbon really vary if we look at building typologies? And this is just one of the studies from CEPT University looking at affordable housing buildings in 5 cities, and they have of course used LCA, which is life cycle analysis, and the gray here refers to embodied carbon, the yellow refers to operational carbon. So as you can see, the lowest life cycle carbon will be if you select a walling material like EPS core panel and AAC blocks. And these are projects which are the typical affordable housing projects in these 5 cities. And embodied carbon is currently accounting for 93 to 95% of total life cycle carbon, which is huge, as you can see. I mean, typically we would assume that residential buildings will have, a large amount of operational carbon, but it's not true. Residential buildings typically have a large embodied carbon, and it's sort of like the reverse in case of commercial buildings is what we have experts say. Some of the operational energy benchmarks that have recently come out for existing buildings, and this is again just to give you a state of play on where our knowledge on energy efficiency as far as buildings is concerned, where are the benchmarks. These are some data sets from the work that BE has been doing on operational energy benchmarks for different building typologies. Here we have presented the residential, the commercial buildings, including BPO, offices, hospitals and shopping malls, and a large part of this data has been used to create the standards and labeling program for the buildings, for commercial buildings. There are also recent studies done by AEEE on benchmarking of hospitals. AEEE stands for the Alliance for Energy Efficient Economy, which is a premier think tank based out of New Delhi. And they had recently completed a survey of more than 600 hospitals across different climate zones to identify benchmarks for energy performance of hospitals. And this is just to give you a sense of how much the EPI tends to vary depending upon the location of these hospitals, which also includes primary health centers in rural locations as well. If we basically just try to combine it all, and if we have to look at the whole sector in sectoral strategies in one go, this illustration here is interesting because it basically points to the fact that majority of our decisions as far as the trajectory of whole life cycle carbon of the building is concerned will come from the planning and design stage. Do we build at all? Do we really need to construct this building? Is there a way to repurpose buildings? Those are some thought processes which have to be considered right at the planning stage. Then designing buildings in a manner that you immediately reduce your embodied carbon by selection of materials that are more efficient, and basically looking at structural interventions at the time of construction of buildings, and then the remaining pathways for decarbonizing buildings which come at the operation and maintenance stage. So this is what we would like for the audience to keep in mind, that large part of our carbon reductions are going to come from the planning and the design stage itself. And if we dig a bit deeper into the different strategies for operational carbon, here India has done, as far as policies regulations is concerned, has done quite a bit of work. So there are these 2 key strategies. You look at the renewables based grid and you look at building energy codes. In both these aspects, we have policies, for example, we have the ECBC, we have ENS, we also have regulations to promote the integration of rooftop solar PV. So all these aspects are there, and therefore, from the operational carbon perspective, we are going to dig a bit deeper into what else is that we are not doing, which we really need to target as far as research and development is concerned. Moving on to the goals of the roundtable and the format that we would be following. So our goal for this particular session is to basically get all the institutions together and experts at this platform to develop a collective understanding of the knowledge and research gaps in building decarbonization in India. And we hope that through this process, we would be able to deliberate on challenges and opportunities in deploying whole life cycle carbon reduction approaches. The structure we are going to follow is, and we are a bit pressed for time because we started a bit late, so the duration is likely to be close to about 120 minutes, probably not 150 minutes entirely. And we would be dividing the deliberations into 2 rounds. The first round where we would be touching upon reducing embodied carbon and end-of-life carbon, which will be the first 90 minutes or so, or maybe about first 60 minutes. And the second half, which will be about reducing operational carbon. And for each round, we would be presenting the context on the topics being discussed, and not to go into too much detail on the research agenda, the research that is already there, because we do want to give time for the audience for the Q&A part. I'll quickly go into the discussions, and I'll invite my colleagues to co-facilitate in a bit. If you look at the discussion on the strategies to reduce just embodied carbon and end-of-life carbon, as I mentioned in the beginning, a large part of our reductions are going to come from just changing our design and construction practices. So taking lean construction as a construction philosophy, minimizing wastage, looking at building form and structural systems, and most recently, there has been an influx of use of prefabricated materials and modular structures for construction, which could also incorporate salvaged materials, and looking at how do we design buildings and thinking of the circularity of it. And interestingly, there has been some work done in this space. We have just here tried to briefly summarize what is it that we know about what is being done to touch upon building design and construction. So some of you are already familiar with IIT Madras's Center on Low Carbon Lean and Clean Technologies, which has been established as a one-stop solution for promoting lean technologies and lean construction technologies. IIT Madras has been doing a lot of work on training and capacity building, on implementing lean concepts in Indian construction sites. As far as the structural systems and construction technology systems related strategies are concerned, and prefabricated modular structure related interventions are concerned, BMPTC and CBRI both have been doing a good amount of work on creating compendiums, creating resources for these new alternative forms of constructing buildings, which are low carbon, more sustainable, have low environmental impact. And these compendiums are fairly extensive, talking about different technologies, their attributes, their application in different climate zones, etc. Coming to the second strategy, which is on the production and selection of low carbon materials, we of course have technologies to reduce carbon intensity of materials. We have colleagues on the panel who will talk about some of these technologies which are penetrating the cement and steel sector, but also the bricks industry. How do we test and pilot some of the new innovative low carbon materials, and we have colleagues talking about that. Standardizing new and innovative low carbon materials, and all of this will not be possible if we don't have the data and tools to support decision making, and the policies and regulations that require and mandate data collection and disclosure on embodied carbon, for example, environment product declarations. And here the research is pretty intense. I mean, we have split it across different slides, but I'm just going to pick maybe one from here. The GKSPL, we have Shashwati from GKSPL, which has done a lot of work on the brick sector. How do we ensure resource efficiency in the brick sector? What kind of standards can be developed for energy efficient bricks? And therein, their work was used to set standards for low carbon bricks, which were launched by BE in 2020. We also have some ongoing work at both IISc and in some other organizations on LC3, and looking at blended cements and other types of composites. Again, not going into the specifics of each of these. There are now there are standards for not just the blended cements, but also standards for LC3. Some work has been going around on that. Some pilots on a thing called geopolymer concrete. CBRI particularly has been focusing on developing geopolymer concrete and building products. And most recently, CSTEP University has been trying to collect all this information on the embodied carbon of different materials and developing an embodied carbon database, which would be very beneficial for the sector once it's online. And if we look at the sort of the next generation of low carbon materials, innovative materials, some research going on bio-based materials, which will sequester carbon, and also on mineral-based materials. So we have Dr. Karadev from CBRI. His team has been working on a variety of materials, looking at agroforestry residues, crop residues, which have carbon sequestration benefits, mineral-based technologies like the one that ISC has been partnering with different institutions to produce materials which basically absorb the carbon dioxide being produced through industrial processes and produce new materials and bricks which could be quickly adopted in the local construction practices. Coming to the last part, which is the reducing of end-of-life carbon, as I said, designing for circularity, standardizing recycled materials, policies and regulations which would require mandates be put as far as C&D waste usage is concerned. Those are some of the areas where we can see a lot of impact if reducing end-of-life carbon is concerned. And there is some research going on, not a lot, but the institutions have started looking at it very closely. As far as circular design principles are concerned, we have to start right from the tool stage, giving the designers, giving the construction industry the right technology and tools to make better decisions. So for example, BIM-based deconstruction assessment scores have been developed by Anna University. We also have a theoretical framework on how you utilize C&D waste and use it as a part of the BIM, these tools being developed by IIT Delhi and also by IIT Madras. On C&D waste management, we have development alternatives here, which has done a significant amount of work on understanding resource efficiency in the construction sector, particularly at the local scale. What infrastructure is available? How do you segregate C&D waste? How do you process it? How do you take it forward? So I hope Mohak can talk a bit about that. And lastly, on the use of secondary raw materials. So herein we are looking at different aggregates and different types of compounds and bricks and blocks being produced using C&D waste. BMPTC has done some work on this by creating a reckoner document, and IIT Madras and CBRI Roorkee are also front runners as far as looking at some of these secondary raw materials is concerned, which are produced at the end of life of the building. I'm now going to invite some of our co-facilitators, my colleagues Deepak Tiwari and Shiny Sam, who are going to lead this discussion. But I'll leave you with this. These are some of the gaps and challenges that we've identified. We did talk about the role of lean construction, but there are institutional and behavioral barriers to adoption of these approaches. There are also conflicts between having a resource-efficient structural system and thermal comfort, some of the other performance metrics that we typically use when we look at energy-efficient buildings. So not just efficient, but also thermally comfortable. What about technologies like 3D printing? What are the environmental implications? There is not much known about that in the Indian context. We also have very limited research on construction materials that are of high quality to withstand assembly and disassembly and have a good recycling potential. Recycling and reusing of steel structures, some work ongoing on this, but not a lot to cause industry-wide transformation. And on bio-based materials testing and standardization, and I hope Dr. Karade can speak to that. And finally, no certification of secondary materials. So these are the gaps and challenges, and this is what we would like for the key discussants to also help us understand that whether these are the right gaps that we have identified. And we would now move to the discussion quickly. As I said, Dr. Swami Maiti is not here, but we have the remaining key discussants here. We have Dr. Sukhdev Karade, we have Shashwati, we have Akhil Singhal, Mr. Rajneesh Sareen from CSE, Mohak from Development Alternatives, and we have our fellow colleague Ankita Gangotra from WRI US, who leads our work on steel and cement decarbonization. With that, I'm going to invite my co-facilitators, Deepak Tiwari, who's my colleague in the buildings team, and Shiny Sam also to co-facilitate this discussion.
Thank you, Sumedha. So we'll be now starting the discussion on the embodied and end-of-life carbon. So I think one of the questions that is displayed on this screen is we wanted to hear your reflections on the research summary that has been presented. And also we would like you to talk about your work in this particular space. What are the key research questions and gaps you are trying to address, and what are the challenges on scaling and deploying strategies presented? So this is the first round of question, and then we can have a follow-up round after all the speakers have spoken. So we'll start with Dr. Karade.
Thank you, Deepak. Good morning, all. First of all, I would like to thank the organizers for inviting me and giving me opportunity to talk to you. I am from CSIR, Central Building Research Institute, Roorkee. It is one of the constituents of Council of Scientific and Industrial Research. This institute is a premier institute in India, which works on almost all the aspects of building science and technology. So the unique thing about this institute is that it has various disciplines, architects, then we have geotechnical engineers, structural engineers, mechanical engineers for automation of the buildings. We have fire research engineering group. Then we have new materials, rural building engineering, and many other things. So we have all disciplines. So that's the uniqueness. Now I come to the what research we are doing in the area of carbon reduction or eco-friendly materials, that kind of thing. So as you most of you know that India's economy is dominated by agricultural activities, and during this activity we generate a lot of waste. On the other hand, in the forest also a lot of waste are generated, which are either burnt or there are issues of forest fire and those things. So most of these are constituents of lignin and cellulose. So it's the lignocellulosic materials. So some of the materials which CBRI has worked is the pine needles, bagasse, rice husk, arhar stalks, hemp. Then there are other materials like industrial material, fly ash, red mud, slag, and we have also used some of the leaves of the trees for making corrosion inhibitors. Presently the corrosion inhibitors are coming from the synthetic materials, and they also contain certain toxic materials. So when they leach out from the concrete, goes to water bodies, and they cause they are quite harmful for the flora and fauna. So we are developing the corrosion inhibitors also from the forestry waste. Then we have also worked on CND waste. The technology is also transferred to the industries. And then besides these materials, the institute is working also on energy efficient buildings, including passive design and those aspects. LC3, there's a low carbon cement, and green retrofitting of the buildings. Now I come to the this organic waste or forestry waste and those things. So the issue is that with forest waste, the issue is there fire. Main issue is this thing. With agricultural waste, the issue is that mostly either they are using for fuel or for their animals, this thing to accommodate them. But the main problem is when they dump it or say landfill, it goes to landfill. So they rot and then create methane and other greenhouse gases. So it has more harmful effect than carbon dioxide. Otherwise, they burn, like parali is one of the issues. Similarly, that issue is there. So how can we use them in building material? So as you know, they are lightweight. When we incorporate them in cement matrix or inorganic matrix, they will reduce the density. When density is reduced, so your thermal conductivity will reduce, and then it will bring more energy efficiency to the buildings, or bring more thermal comfort in the buildings. So that's the thing, but it's not a simple thing, because from when these organic materials, they are incorporated in cement matrix. Cement is highly alkaline material. So under that environment, the extractives from the organic material come out, and they retard the setting of cement. So that's the biggest challenge. The other challenges are their availability throughout the year, their availability throughout the country. So these are many things are localized available. So we cannot develop a generic technology which is applicable everywhere. So we have to identify those areas. So we have come out with the technical challenges and those things. We have produced the building materials like wall panels, wall blocks, then tiles, floor tiles also. So they are giving all right these properties. Unfortunately, the acceptance is market is not that good. There are very few takers because there are lack of building codes, lack of specifications in schedule of rates of our engineering departments. So if there is no demand created by government itself, where will it be sold? So there are very few architects who dare to try with the newer materials and this thing. Otherwise, they also go with the conventional materials. So those are the some of the issues we face. But with C&D waste, is same thing is happening. We have developed technology for use of fine aggregates also, recycled fine aggregates, and coarse aggregate also. And you know the main challenge with the C&D waste is that the double interface when we make the concrete with them. When we get the aggregates, there is a already adhered cement paste. So between the cement paste and aggregate, there is a one ITZ, it's called interface, which dictates the properties. And when we make the concrete with that aggregate, then another interface is generated. So these two interfaces govern the property of this thing. So we have developed the technologies to remove the adhered mortar, and the aggregate then become like a natural aggregates. So the for fine aggregates particularly, or both coarse aggregates, from acidic solution we are removing this thing, but that solution again we are making use for making cement accelerator, setting accelerators. So everything is used, nothing is waste in that process. So that's a wonderful product. Then there are many, if I talk detail.
Second round, sir.
Yeah, sure. So I will cover the properties or particular issue is generated, then I will reply. Thank you.
So next we can go to Sashwati. So Sashwati, if you can reflect on the research that was presented and also about your work in this particular area and the gap you are trying to address.
Yeah. I mean, in terms of embodied carbon, that is something that Green Tech has recently started looking over the past 1.5 years or so. So, you know, a lot of this we are waiting for, like the research to come up and say in terms of, you know, materials, what are the new materials that are coming, so that we can see how they can be integrated in buildings and how the building comes up, you know. Okay, so Green Tech, we primarily had been working mostly on operational energy, like energy reduction, energy consumption in buildings. So the code, especially the residential code for energy conservation building code for residential buildings, that was developed under the Indo-Swiss Building Energy Efficiency Program, which was managed and executed by us. So on the operational side, we have been working for a long time. But of course, at that point of time, you're just looking at, okay, energy efficiency in buildings, right? And then when you come to carbon, now you have to look at the whole life cycle. And because we had some experience of working in the brick sector, specifically, again, looking at from the angle of how do you make brick manufacturing more efficient and less polluting. That was the angle that we were looking at. But since there was this background of it, so we said, okay, we can then, you know, kind of go forward with the embodied carbon side of things also, because you're doing certain measurements and raw material measurements in brick sector. So those things also could be done. Now, as I said, last 1.5 years or so, we have also started looking more deeply into embodied carbon of specific materials. So what we are doing there is basically we have looked at 3 specific materials, concrete, steel and brick, in much more detail in order to kind of support the development of an embodied carbon database of building materials. This is something that CSTEP University is working on, and while developing the database you need to do some testing, like, okay, what kind of information is available with the material manufacturers, or, you know, in research, what kind of those carbon emission factors and things are they available, to what extent are they available. So in order to kind of test out like what could be possible, to what detail will that embodied carbon database framework look like, we kind of looked at the 3 major materials, cement, steel and fired brick, and see, okay, what kind of information is available. Are we able to, you know, look at, you know, disaggregate the carbon information into A1, A2, A3. That was our scope. We were not looking at the deconstruction and, you know, demolition side of things, because anyway that is I think everybody knows the data at that side of things is even more difficult. So A1 to A3, usually the major organized material manufacturers would have them. Brick, on the other hand, is a totally different matter. It's unorganized, so even getting like input data is very, very difficult. So there, like you have to depend on research, specific material researchers. Okay, so those are the things that you are kind of finding out, that when you have to get data, then what is the source of data that will be there, you know. So during this exercise, that was something that we were doing. Another exercise that we are doing, another assignment that we are doing on embodied carbon is embodied carbon of buildings itself. Like if we have to, for example, you have an EPI benchmark for operational carbon. I mean, that's the analogy that I can give. So when you say embodied carbon normalized across a building, now whether it is going to be built up area or carpet area or some other kind of area, that is still to be seen. But how do we do it? What is the possibility of doing it? Again, what kind of data is available with builders? Because, you know, builders, they jot down data, or they record the material data in a different way than how, you know, if you have to do embodied carbon calculations, how would you want it? So looking at that, and then also seeing, like, you know, what is the share of, say, operational versus embodied. So because we were able to have access to 3 buildings, their material quantities and all of that, and through simulations, so that is something that we are trying out, in the sense that how much embodied carbon, how much operational carbon, in embodied carbon, how much goes to superstructure, how much goes to substructure, what is the whole thing, basements, building envelope, windows, how much does it come to it. So those are the things that, so I was quite interested in what was shown by Sumedha, in the sense that the housing thing. I mean, so there one needs to take care of the thing that I'll have to recheck those, but then that high embodied carbon, low operational carbon, that is probably because it's affordable housing. You go into a different type of housing, it will be different. So all of this, so whenever if policy we have to make something of that sort, then you will need to kind of look at how do you bin buildings? How do you categorize buildings? That has to be done a little bit more, like, carefully, to see, you know, what kind of benchmarks we set. So that is something that we are working toward right now.
That will vary according to building type also, whether
Yeah,
it's a
yeah,
residential
absolutely,
building or a commercial
absolutely.
building.
There are a lot of complications right now, but what we are trying to do is, you know, slowly look at, you know, kind of sort through the complications of it.
Thanks, Ashwati. So we'll move to Dr. Rajneesh Sareen, sir.
Yeah. Good morning, all. First of all, I would like to congratulate WRI, because this is one of the very important subjects which we should look at, because country or internationally, nationally, we have been talking about cradle to cradle, but our approach has been always cradle to grave. So reason for that are there multiple. For example, so at CSC we work at all the stages. What we understand is, like, even for example, if you look at housing as one of the sector, so the builder or the person who's going to build this, his life cycle is for 3 years. Now how he's going to design something which is cradle to cradle for you? So his thought process works only at the 3-year horizon, whatever is the construction period, then he moves out. Our PPP instruments are also similar in that direction, because it's like 3 of the construction. Many of the PPP do not, like in case of affordable housing also, when we introduced this public-private partnership enterprises, there was nobody who was there to take up for at least a longer period durations, whereas 20 years is concerned. So most of the time the people come in only for the EPC contracting, and that's where the decision become very poor. Now you do not have a bandwidth to absorb these materials, and as well as think about that what kind of fusions we need. The experimentation is very narrow in that case. Like, for example, if I want to play with C&D waste mixes into the new construction and want to bring down the embodied carbon, my life cycle is for 3 years. And after that, somebody else is there and I don't know who's going to take. So that where the subject becomes logically very weak. So at industry, you definitely have a potential, because industry has a decarbonization game with them. Like cement you can reduce, steel you can reduce, because they will, at least somebody is the owner of that and can take share of it. But the moment you enter into a building dimensions, it is very difficult. And so far government has not even experimented that, because this is a huge stock of carbon which government could actually really shuffle it around very well. But because they are not focusing, or neither there is any great demand coming on this side, so industry becomes one of the very weakest component. And as the construction becomes weak, automatically your reutilization or your, you can say, the end of the pipe treatment also become further weaker, and that's where the C&D comes in. So now I think this is a good discussion where we should bring in that how we stitch this and strengthen these aspects together. Until unless they are not done, it will be very difficult for you to stitch them together. And I think you really pointed out into various gaps, which I think maybe the discussion will open up more on that.
Thank you, Dr. Rajni. Over to you, Mohak.
Thank you. Good morning, everyone. So I'm from Development Alternatives. DA has had a long history of working on the buildings and construction space, specifically from the building materials and technologies incubation, development, mainstreaming. So currently also a lot of the work that we're doing is in the building material space, right from technology development. LC3 was mentioned a few times. DA has worked with IIT, Madras, Bombay, Delhi and SDC along the years to sort of bring LC3 to fruition, now also working closely with cement companies to mainstream that product. So there could be cement, a lot of work has been done in the brick sector, especially even from moving from burnt bricks to fly ash bricks for state level action, let's say in Bihar. Currently, a lot of our work is focused on the other end also at looking at bringing in new sustainable materials into the affordable housing space and looking at it from the state level subnational action point of view. So what do states need to do, what do cities need to do, and combining strategies towards policy interventions, but also how do you move the market. That has been sort of the mainstay, and it was quite interesting to see today in terms of the research that was presented. A lot of focus was on the design and planning stage, and that is where we do also see a lot of gaps in the market, because even when technology solutions are available, even when policy is conducive, why don't we see enough architects and developers sort of delving into these spaces? Because it's not always a case of regulation being missing. For a lot of materials that have been in the market, the standards are there, policy allows for it, technologies are there, materials are available, but still within the design and planning stage, we're not experimenting as much with what already is there, and therefore experimenting with what needs to be brought in new is another next step altogether when we talk about modularity and designing for disassembly. Those things seem quite far-fetched even in a space where we are right now, where prefabricated technology refuses to take off as much as it should because of a lack of skilled workforce. So there are those various gaps along the value chain. That's kind of the work that we have been doing, and very excited to see like what all comes out from today's discussion as well. Thank you.
Thanks, Mohak. Over to you, Akhil.
First of all, I would like to thank WRI for organizing this, and then yeah, okay, I'm audible now. Yeah, cool. First of all, thanks to Deepak and WRI team for organizing this. Pleased to be here. This is, as Dr. Rajneesh also mentioned, very timely discussion on embodied carbon. What RMI has been doing, as you could have seen on the slide deck, that we have broken down the building emission spectrum into several spaces, and now we are trying to categorize it into pre-construction, during construction, and post-construction. That's what we feel is the lifespan of a building. So when we talk about pre-construction, thanks. So when we look at the design side of things, so we have moved away from the building design itself and now looking at the urban design of the space. So while we feel the architects in the communities that are there with the developers, they're very much trained to build efficiently. Right now we are working with one of the largest developers in the country, and then their building designs have led to a EPI value of 41, which is by far the best in what we were able to achieve. We did some literature reviews and some stakeholder consultations, and in 2016 it was coming out to be 45. Right now we are sitting in 2024, and then from the last year data it has been 41 on the operational side, including the equipment load. So we certainly feel that the designers have cracked the game in terms of building design, but when it comes to urban efficiency, we are looking at integrated design approaches. Now during construction, there's a lot of work on embodied carbon that we are doing, starting bare bone from the benchmarking side. So we broke down again the building into several components and then zeroed down on what are the top impactful materials. So 70% of the embodied carbon goes from concrete and cement, steel and aluminum. So if we are able to solve for these three sectors, we feel that we could be able to solve for the larger purpose of embodied carbon, and that's where we started with the benchmarking exercise. Lodha right now is roughly at 400 kg CO2 per square meter, whereas when we started to compare it with other Indian benchmarks, there were none available with us. So we identified that as a gap, and I also see that in your work at WRI. So we certainly feel that there is a larger scope for the entire group to partner and develop those. Apart from that, we are doing a lot of pilots and evidences. So when it comes to either LC3 or GGBS or geopolymer-based cement structures and concrete structures, while the code itself allows for 70% of GGBS integration in the concrete admixture, what we have seen and observed that the developers are not going above 50%. There are issues related to structural stability. There are issues related to people, how do they see the building construction itself. So not a lot of developers are adopting that, while there is a code that has been put out there. Internationally, we have seen in the US, the buildings have gone up to 75-80% of GGBS integration, but that's not the case in India. And it's not only because the developers' hesitancy. Even the material, if you look at it, there are only two GGBS manufacturers that are available. So it's in terms very limited availability of GGBS when it comes to the supply chain side of things. So where we are also working in supply chain management and enhancing the capacity of the supply chain itself, as well as the how the supply chain works. So when we were looking at LC3 pilot very recently at Lodha, what we realized that there's no market availability of LC3 cement right now. It is being mainstreamed, as Mohak mentioned. However, when we wanted to get that done in a 3 months time frame, so we couldn't find the material available right now. There were no environmental clearances that were available with the companies to produce LC3. So that's something we're trying to shape up and then bridge the gaps there. In terms of post-construction or operational efficiency, we are working with Lodha developers again, trying to reduce their energy performance index. So right now it's at 41, the aim is to reduce it to 27 and at the operational side.
Yes, over to you, Ankita.
All right. Thanks for inviting me here, and good morning, everyone. Let's talk about cement and steel. And my colleague here very rightly said that, emissions-intensive products like cement, steel, and aluminium account for a majority of the emissions in embodied carbon. In fact, cement and steel accounts for about 60% of the emissions in embodied carbon. And also, a majority of embodied carbon emissions come from the production phase. So 65 to 85% of the emissions, right? So it's really important that we talk about cement, steel, and the existing emissions-intensive products. So when we look at cement globally, it accounts for about 7 to 9% of our global CO2 emissions. Steel is at a similar number. So combined, there are about 15% of global CO2 emissions, right? And to put that in context, if cement were a country, it would be the third largest CO2 emitter, right? Similar to all of India's CO2 emissions. So it's a huge challenge, that really needs to be faced. And of course, one of the biggest challenges is that the demand for these products is going up. So we know that in India, cement and steel demand will triple by 2050, and emissions will increase similarly, right? So some of the key steps, I focus mainly on the upstream emissions. I focus my research on cement production and steel production and how do we decarbonize that. But as I understand it, when we look at embodied carbon in the built environment, there are some key strategies, right? So we've got reducing the amount of clinker that we have in cement that we have in concrete that we have in buildings, right? Reusing or recycling of these products, especially with scrap steel, etc. Replacing these products where possible using alternative materials. But mitigation is also key. Actually reducing the amount of cement and steel production emissions, because these materials are going nowhere. They'll continue. We can't fully replace them, right? So that's really important. And these sectors are considered hard to abate because of a few key challenges. So demand is one of them. Another big thing is that these are precision engineered tools, materials, right? They've been used for decades, centuries, very well. And now that we've come to the climate imperative to decarbonize them, there's low market acceptance for other alternatives. They have very low profit margins. They're usually cheap materials, right? And one of my favorite reasons, and one of the key reasons why we need to focus on this, is that they also have process emissions. They have, it's not just energy or thermal combustion that causes emissions. It's chemical reactions that cause emissions. So if we look at cement, about 50 to 60% of the emissions are because of literally turning limestone into lime that releases carbon dioxide. So that's really the scale of the problem. My research focuses on the US and what's happening globally. So within the US, we work really at 3 different levels. I work on California. So California is one of the first jurisdictions in the world to put in a mandate for zero carbon cement by 2045. So how do we get there? What is the roadmap? What are the policies and technologies needed to implement that? At the federal level in the US government, we look at things like policies that need to be put in place to scale these technologies up, because we know that so about 60% of the cement and steel decarbonization or industrial decarbonization technologies are still in the development pipeline. They need rapid scaling up. So what are the policies that we need in place? And then at the international level, it's really important to focus on international cooperation, and that's something that we focus on as well. Harmonization of standards, etc. EPDs, environmental product declarations, and what do they look like? Are they interoperable between countries? Because these are traded goods as well. So that's really where I focus on. I mean, I can get into the technology solutions, the policy options, but I'll leave it there for now.
Yeah, thanks Ankita, that was wonderful. So I think we had a good round of discussion, first round discussion. So I have some key follow-up questions for the key discussants. So I'll move on to Dr. Karade. So sir, you talked about this crop residues usage and the agroforestry waste materials being used in the building materials. So wanted to understand how effective are these materials in terms of their structural and functional performance for the building as compared to our conventional materials, and what are the challenges that are being faced in bringing these materials into the mainstream construction industry, especially talking about the research that you are working on the hemp concrete, because this is also a material that has been listed in BMTPC documents also.
Thank you. Actually, we are working on various agroforestry waste materials. Hemp concrete is one of them, which has drawn a lot of attention. As you know, hemp, or in Hindi you call ganja or bhang, so it's a wonderful plant. Actually, its roots has a very high Ayurvedic drug value. Then its seeds has also very high drug value. Oh, sir. Okay. So that's a wonderful plant. Then the fiber from the stems, it's comparable to silk. So that is also sold. So only thing remains is it's a stem, woody material. So what we do, we grind it. After grinding, we bring it to certain particle level, and then with this lime or other binders, we make concrete. So there we can achieve as low as about 300 kg per cubic meter density, and the thermal conductivity is also around 0.05 watt per meter Kelvin. So very low thermal conductivity. But unfortunately, at that density, the strength is very, very low, around 0.5 to 1 MPa only. So when we increase the density, so when bring it to 400 to 600, there we can get 2 to 3 MPa density and quite reasonable thermal conductivity. So that kind of material can be used for non-load bearing material structures. For example, infill wall panels or thermal insulation, or filling the cavities between the walls. So that kind of application we can use with it. So it will provide a lot of energy efficiency in the buildings. The other advantage with this material is hygroscopic in nature. So as you know, in many hot and humid climate, even at lower temperature, we feel very uncomfortable because of high humidity. So this kind of material can absorb the excess humidity and make the indoor environment very comfortable. So it has very wonderful properties and those things. And now the production has started in certain areas. The challenges are that it is still banned because farming is not allowed. Then in certain states like Uttarakhand or Odisha, I think in some part of Maharashtra, with the permission of state government, you can do the farming. From that you can get this kind of material. But it's a widely grown and those things and is still available to many places. So that this thing, but it's not available anywhere. That's one challenge. The other challenge is that when we want to increase its strength to make it comparable with the fly ash bricks or conventional bricks and that kind, then in lime binding we cannot get that strength. Then we have to go for other metrics like geopolymer. In geopolymer, when we make bricks and bring it to 12-13 MPa, then its embodied energy is very, very high comparable to when compared with the fly ash bricks. So then we have to modify the matrix, because in geopolymer, particularly the sodium silicate and sodium hydroxide, their embodied energy content is very, very high. So if we can replace that binding material with slightly lower, then if compromise to bring it to 7 to 8 MPa, that's what we are trying to do. So that will be comparable with the conventional material. So these are some of the challenges. Then with other agroforestry materials also.
Talked about the technical challenges. Are there any challenges related to development of standards for these materials or certification of these materials also?
Exactly. Actually, there is no code still available yet available for such materials. Therefore, we are comparing with the irrigated concrete blocks and those things. But there, we cannot get this hygrothermal properties and other things. So the other main issue, what our topic is about the carbon content in this thing. You see, if we are using the lime based matrix, then it's a carbon negative material. It's a minus 300 kg per cubic meter, because it continuously absorbs carbon dioxide from the environment. But there is an argument that for getting the lime, we have to burn the limestone, then only we get. So there you emit the carbon dioxide. So while consider that and the photosynthesis effect of the plant and those things, then it comes around minus 84 kg per cubic meter. So still it's a wonderful material. But unfortunately, this is not widely publicized and those things, and this material is also not widely available. So it will not go. But those architects who have seen the properties and this thing, they are quite interested. And in few new buildings, I think they are going to bring it. Thank you.
Sir, I have one more question. On the CND waste also, you touched on the opening remarks.
Yeah.
And you have been developing some bricks and blocks from the CND waste materials.
That's right.
So how far is the market ready to accept these type of materials? And also, are there any secondary material certification established in India for these materials?
Actually, on 13th June, we have an industrial meet here in Stain Hall. So there the industries, municipal corporations, authorities, have representatives of all departments were present. So the main view was that first thing is no systematic data is available on the availability of CND waste in different cities. So now the objection comes from the industries that how any entrepreneur will set up an industry when he doesn't know what is the availability of raw material, and then who is going to accept and what is the demand. So that for demand also there is no systematic data available. So we have made some certain recommendation that government authorities, particularly from CBCB, who has issued guidelines in 2016, and BMTPC also issued certain guidelines in 2018. So they should further go and generate the systematic data, getting inputs from the municipal corporations of various cities. So when there is a certain, say about 10 years or 15 years, then there will be some stability in the data generation. So that will be helpful for the investors to set up industry and this thing and make the products. As far as research is concerned, we can get comparable properties, but in this thing, recent code 383, they are only limited up to 25% of CND waste is allowed in non-structural concrete. Okay, So we cannot make still RCC structures with those concrete, but in non-structural components like your blocks, footpaths, or walling blocks, other things we can use them. So we have developed a technology and transferred it to a Nagpur-based company, Disha Construction. They are using for their own construction, so they are quite satisfied with that. In CBRI also we have a technology demonstration park where we have used in building components. So by looking that exactly there is no formal technology transfer, but many construction industries are looking at that and they are using in their own construction. Thank you.
Thank you, sir. So moving on to Shashwati. Shashwati, in your opening remarks, you touched about the brick sector, the energy efficiency work that GKSPL has done in the brick sector. And in the presentation also that Sumedha presented, we saw that the brick, the work that has been done by GKSPL on the brick sector was adopted by Bureau of Energy Efficiency to set up a certification system on that. So could you tell us about what happened to that particular certification systems? What has been the challenges in particularly in the brick industry on energy efficiency or getting the energy efficient bricks?
Okay, so yes, the EC3 it was called, no, or E3C, sorry, E3C. And it was not so much on the embodied carbon side of things, it was more to certify on the operational side of things only. So you would have thermal properties and all of that. And that scheme was developed, also presented to Bureau of Energy Efficiency, but frankly, I do not know what has happened with that scheme. So it was commissioned by them and, looking at all of that, but I guess you need some champion to push it, and even within the government, this thing. So it is there, it was kind of everything was done and submitted, but the certification scheme in terms of being launched, it was not done. And I'm not privy to what the reasons are behind it. So, but the thing was the E3C, that brick was not looking at the embodied carbon side of things, the embodied carbon side of things, because it was done quite some time back.
Energy part was covered.
Energy part was covered because you would have okay, A, B, C, all these strength related qualities are going to be there. Plus it will also give you in terms of, so basically it would say that this is coming from, you would know that okay, it is coming from a kiln which is not polluting as much and things like that, and the density and the thermal conductivity probably is also this much. And because it was looking at fired bricks, so it was not just about solid bricks, it was also about hollow bricks, and so a hollow brick would get a better certification, say for example, than a solid brick, right? So again, I do not know what's happening there. In terms of EPD, recently I got to know that one of the brick companies, it's called Prayag Clay Bricks, I guess. So they have actually brought out their EPD recently, and it is one of the first that company is they do have extrusion machines and all of that, but it's not a fully mechanized, so to say, like a Wiener burger, you would say. So they had an FCBTK at one point of time, then they shifted into natural brick, zigzag kilns and all of that. But they did come up with their EPD mainly because they also export. And because you export, you will have to, especially if you're exporting to Europe, you do have to get your EPDs done. And that brick kiln, again, they produce many fired products. So they produce clay tiles, they produce solid bricks, they produce hollow bricks, all not hand molded, I would say. I think they're all machine molded and everything right now. But because of use of a lot of biomass instead of coal, natural gas as fuel, and I believe some of the things that could run on electricity in a brick kiln, that was also transferred to their on-site renewable source. So now their A1 to A3 has actually come down to like 1/10 of what you would assume, what researchers have assumed that, a brick produced in India would be kind of, or the carbon of it, the product stage carbon of it. So some information of that sort is scattered, that kind of information is there. I mean, I think that was a one-off kiln that has done it and also brought out its EPD. I know that in, say, for example, in Punjab and places like that, people are looking at, wood pellets as the fuel. So there again, your embodied carbon would go down a little bit. Also, because in brick kilns, the main thing is because of the burning of whatever fuel. So if you burn coal, your CO2 emissions would be higher, and if you're shifting to something else, then yes. And I think, if I'm not wrong, there was some kind of directive or something that brick kilns, especially in the Indo-Gangetic plains, need to move to natural gas. That was some directive that had come from the center. But of course, there is a lot of, a lot needs to be done before it can actually shift to that, because you need natural gas pipelines to be, brought down there and all of that. So right now, I think brick kilns all over Indo-Gangetic plains still looking at a mix of coal and maybe biomass if it's available with them.
Okay, thank you. So we'll be moving on to Dr. Rajneesh Sareen, sir. So, sir, my follow-up question, because you talked about the construction and demolition waste in your opening remarks. So, the follow-up question is on what are the current research gaps related to reuse and recycling of construction and demolition waste for reducing the carbon from the building sector? And are there any best practice examples of C&D waste utilization in India? Because I have seen your report, you have done a mapping of various construction demolition waste utilization facilities across India.
So, thank you, Deepak, for bringing this discussion on CND. CND, first of all, most of the time we try to approach even municipality, as sir was mentioning, is approaching it from a municipal solid waste angle. But when you look at the value and trade chain which is there in the subject, the game turns, then makes a spin. So until unless our way of looking at this as MSW do not change, the lens do not change, CND will never becomes as a resource to you. So there is a huge amount of ecosystem which is required to bring this material back into where we want it ideally to be. Like for example, initially when we started with fly ash, the whole discussion, bringing that into the construction, embedded that, the whole story is narrated there, right? Similarly, the hurdles are there in case of CND. And plus CND is innovating. Fly ash is a standards product with you. CND is, for example, we were non-homogeneous construction material, then became the homogeneous construction material, and now we are moving to non-homogeneous industrially produced materials. So that means every step of leapfrog of technology which we are taking in construction, there is a leapfrog of CND processes which also needs to be developed along with it. So what is the latest, you can say, the estimation which has been there with us of estimation is by TIFAC, which is somewhere in 2000. We are sitting right now in 2024. So that means our benchmark of estimating that, as sir said very well, that there is no estimation or clear estimation is not there. So you are working on a formula which is 24 years old, which was maybe at that time the construction technology was altogether very different. So you don't even know what is coming to you and what quantities are coming. Now, then there's another thumb rule which comes from plant operator perspective. They look at certain grams per capita, which is because they want to look at the minimum viability of that plant to run it. And then these plants has their own connections in terms of, like, for example, if the repetition or the product per day doesn't come in, the break even doesn't come in. So that also becomes one of the hurdles in this whole theory of whatever the application we look at. So there are various things which are associated with CND right now, which needs to be worked very well at, which people needs to have a fairer understanding. So it's just not about a waste which is coming from and then you dispose it or whatever you do, which is right now the practice. Now you are making something which is important structural component for it. So for example, the CPWD experimented this, but their experiment was also accidental, because they wanted a stone-cladded structure for Supreme Court building, and they couldn't do with, they wanted to move away from bricks. The obvious reason, Shashwati has given you various facts of it. They wanted to move, but they can't use AAC blocks, because the reason is AAC having a cladding of the stone, it's not very structurally, so you need to really work on something. So then that's the time when the choice of CND came in. Now when they looked at CND also, Agni Pariksha was much harder for them. Like when you look at the compressive strength of a product, which is a normal virgin produced, and when you are looking at recycle, they were asking for 3 or 4 more times of strength in that. So that they are like, the person is like sure on this, that this no collapse will happen on it. Now imagine there is a doubt which is there in the mind of engineer, there is a doubt in the mind of the CND waste producer also, or the product producer also, and then there is no clear standards for its absorption, because in any case we are not asking it to be used onto any of your direct constructions. In terms of, we are saying, okay, wherever you have like lean, non-structural based or some constitution of that, you can do it, but definitely the risk involved. Now, when you have such kind of modalities, which is like almost every stage is with the risk, how you can expect a material to come in and facilitate and enter into the fabric which you are looking at. So these are some of the hurdles which are there with CND. But yes, now there are good experimentation which is happening. For example, I would like to quote, Chandigarh has done some works where what they are saying is that you pay to us for CND, then take 50% of that material free of cost from it. So at least I'm ensuring the utilization. So you use it where you want to. There are certain places where they're trying to say that let's the self-help groups operate these plants and take the material for their construction. Because in any case, they're taking broken bricks, they're taking something to make their houses, which is thermally comfortable with them. So better is that then give them ownership of these plants so that they can at least make their own construction materials out of it. So with these, I think there's some ways we are opening up now. We are getting little more plants visibilities there. Delhi, for example, is one of the very good case. You have around 5,000 TPD capacity which is operating, and another 4 plants or 5 plants are coming up in pipeline. NCR is like, if you actually look at NCR, you have in Gurgaon, you have in Ghaziabad, you have in Noida, you have in Greater Noida, you have in Delhi around 5 plants. So almost Delhi NCR is becoming one of the very important hub where you are looking at lot of utilization of CND also. But yes, it needs to scale up into tier 2 and other cities which are further away from NCR. Yeah.
Thank you very much for your insights, sir. So I'll be passing the mic to my colleague Shaini for the next round of questions.
Hello, hi, I'm Mohak. During the reflection session, you had touched upon the prefabricated materials not having much market uptake. So based on that, one of the strategies for the end-of-life carbon, addressing the end-of-life carbon, is design for deconstruction, design for deconstruction. So how do you think these prefabricated materials, modular constructions, and removable connectors, these kind of things would be accepted in the market? What policies might help us proceed in these directions?
Hello. Yeah, okay. Thank you for the question. So I think, like how we mentioned before, it is a hard to abate industry because it moves very slowly, and I think we're very reluctant to take up new practices, new construction technologies, and the same kind of challenges that we're even facing for the CND waste, like we mentioned, where technology uptake and the trust in the material is not as such. There is a certain degree of RCA already allowed to be used in concrete, but developers and contractors are hesitant to actually meet those levels. The same way, I think the same distrust exists for precast technologies as well, to a certain degree. And the other challenge with precast and prefab is the lack of skilled workforce and technologies, which are applicable at various scales. In terms of precast technologies, you either have solutions which someone like an L&T would use to construct thousands of houses together, where the cost economics are very, very different, or the other scale currently is where you have small scale precast technologies which may be used for affordable housing or rural housing segments. The segment in between is definitely fairly untouched. So either you have small scale precast in rural housing and such, which could be channels, precast beams and columns as well, and things like that. So I think the first step that would probably be required even before policy is just solidifying the technology and making sure you have use cases that demonstrate the applicability and also the real world applicability in market conditions. So if you're able to showcase the robustness of the technology, that would be a first step, and therefore technology incubation and support becomes very important. tie-ups with academic institutions who are already research institutes, who are already working on these, for them to come together with developers, for them to come together with maybe some government entities, either at the state or a city level, to conduct pilot demonstrations for these kind of things. Um, those are some key challenges that would come first. And with that, I think the role of the architects and designers in terms of how they are able to apply these technologies would then be another barrier to be crossed. But currently, I don't think we have enough demonstrated, replicable, precast technologies which are being applied at scale. There are. I mean, even during the GHTC, there are some technologies that have now been demonstrated. So now how they perform in market, or how well they're able to be mainstreamed into market, is something that we will see probably now. But there are now some use cases, but I think that the advent of technology there is still fairly limited. And I just on the technology front, I know I may be tapping into a different question, but I just want to build up on what was said by Dr. Karade as well as Dr. Sareen in terms of the data availability at the city level. Cities are mandated by policy now, all 1 million population plus cities are mandated to have C&D waste plants, but they have no idea how much they're generating. The methodology is outdated, and there are no tools or frameworks that cities can use. And in that scenario, even something like a material flow analysis becomes a very valuable tool to do some projections of what is the materiality of the waste coming out. Also to be, because there, we also need to be cognizant of the fact that the materiality itself is changing. The buildings that are reaching end of life today have probably a much higher brick content than as you will see 10, 20, 30 years down the line. So I mean, unless you have the accurate estimation of what is coming out and what is the character of that, the quantum and the nature of the waste, it becomes very difficult, like was said, for any entrepreneur to invest into this and say that, okay, this is going to be an opportunity for me to also survive. And in that case, I think at the city level, probably it also becomes important to work with the developers to have some maybe buyback schemes, some incentives, property rebates, taxation rebates. GST, I think, is still 18% on products utilizing circular materials as well. But can that be brought down to 5%, like it was done for fly ash bricks and other materials? So these kind of, like a combination of market and financial policy, I think, changes might also be helpful in as much in C&D, but also towards other precast technologies.
Thank you, Mo. Just as much as this is engaging, in consideration time, I'm moving to. What has been your experiences with the on-ground implementation of low-carbon strategies like material efficiency, low-carbon alternative materials designed for deconstruction by the developers? This is in consideration to Lodha's LC3 update.
Yeah.
What has been the success and failures that you must have faced?
Yeah, I guess I would say that when we started to work with Lodha, I guess it was challenging for us as a CSO community. What we struggled with at the very beginning is how do you understand the developer's mindset? A developer's mindset is very much concentrated around speed, scale, and cost of things. Cost is something that they're happy to further enhance and improve. As at least what we have observed, and in my career span, I've worked with several developers in past capacities, and then understood that cost is not the biggest factor, but it's the speed and scale what they can look at. So when we talk about design materials and material efficiency, so we are not looking at bricks or block work, because why did Mewan scale up so quickly within the entire sector is because it provides you with a lot of speed and reduces your reduces your overall wastage. So you do not need to invest into the formwork again and again. So that's the primary reason, and that's where we are trying to focus our strengths towards, is how do you decarbonize concrete as a design mix and not working in separate silos of decarbonizing cement or decarbonizing steel. So we are looking at the design mix optimization when it comes to Lodha. Specifically looking into LC3 implementation on ground. So when let's say 3 months back, when we decided that we would want to start with the pilot, and we started to explore what are the LC3 manufacturers available within the country, and then we were surprised to see that while the code has been out more than 6 months ago, there were very limited manufacturers of LC3 cement, so as to say there was only one. And then also there has been some challenges that we're trying to also overcome with their production side of things. So firstly, the material is not commercially available as of yet, and it is bound to happen in, let's say, next month's time frame or maybe 2 months time frame. That would happen, and then we are very certain that we would become one of the first developers to move ahead with the pilot demonstrations of a LC3 based building. The second hesitancy we are trying to break is on the RMC or the production line of things. So building out capacity for the RMC vendors, because the RMC vendors are not ready yet to invest on the production line when it comes to the LC3 cement. So we are trying to put out advanced market commitments from different developers' side. So Lodha has been one of the developers who has committed, but we are trying to bring partners who can also put out an advanced commitment when it comes to the setting up a production line, because market hesitancy, people are not ready to invest in the production line when it comes to the LC3 cement. Apart from that, we are working with the capacity building of the technicians as well as the masons on how to utilize that best forward. So what we have improved and incorporated as a design practice or as a best practice is that we have put out QR codes within the built environment, and then as soon as a mason goes to a particular space, they can just scan the QR code and get to know what best is required to be done there with specific materials that have to be selected, so that there's no wastage as well as the design is optimized. So that's where we are investing with the capacity building of the masons as well.
Thank you. So Ankita, I would request you to conclude your answer in 2 minutes, and we'll move to Q&A. So sorry about that. You have been studying the cement and the steel sector's decarbonization pathways at the industry level. So for the cement sector, process level energy efficiency, alternative fuels and raw materials, clinker substitution and CCUS have been identified as a key strategy. So some studies say that without CCUS, you cannot deliver or achieve net zero in cement sector. So which of these do you think India should be heavily investing in?
I think it's in all of the above answer, really. It's true that we're probably absolutely not going to get to net zero emissions in the cement sector without some amount of CCUS, right? The jury's out on what percentage, but it's significant. I've seen roadmaps that say anywhere between 30 to 60% of the emissions reduction will come from CCUS. But the issues with CCS or CCUS is that, it's still to be tested at scale globally and also in India. GCCA, the Global Global Cement and Concrete Association, just came out with a report. I think it's the first of its kind, looking at the scope and capacity of CCS within India, and that was an interesting look. But really, I mean, the technology needs to scale up. We need the infrastructure, the pipelines, etc. So all of that is there. So it's almost like a long-term, long plan. Whereas in this short to medium term, we've got options like clinker substitution and fuel switching, etc., which are really important. And at the same time, we need the policies in place, because even if you have especially when it comes to clinker substitution in something like LC3 or even PLC, or increasing the amount of SCMs in cement, we need market acceptance. And for that, yes, we need pilots and demonstration scale projects, but we also need public procurement to do its bit. Globally, 40% of the cement that we use is used in public sector projects. That number is 25% for steel. And so really, the public sector has a huge role to play here in really kickstarting that shift from emissions-intensive cement and steel towards these alternatives.
Thank you, everyone. We do have a couple of minutes for Q&A, so just want to also give the audience the opportunity to interact with our discussants for the embodied carbon, on embodied carbon and end-of-life carbon. So if people have questions, please raise your hand. You can say your name and then ask the question.
Thank you. Hello. Yeah, so we have heard, my name is Vaibhav, I'm from Smart Joules. We have heard a lot about embodied carbon and operational carbon. I wanted to understand a little more in depth with the help of an example. Say this very building we consider, is it only the materials that are going into the building that come under embodied carbon, and how is it different from operational carbon? And is there anything that we occupants or the equipments which are there in this building that are generating heat that also form a part of the carbon that we're talking about? So if anyone could help with an example.
So if I take a small example of this, the energy required to bring this onto my table is what is behind the scenes, right? And in case it does something, like for example, emit heats or something as a product, then it comes something which is in the domain of this building as such. So whatever this material travels with to the site, it's something which is, you can say, a load which is already there with that material. Now this is something which could be easily dealt with if you try to look something which is locally recycled, low carbon, your thought process, so depending on what material selection you do. So this will bring down that carbon, because this is where you need to really study well and research well. So whatever Shashwati has given you in terms of that 1, 2, 3 are the stages which happens in industry, you understand that how far, because so far we don't have a tagging, but cost is a tag to it. So whenever you look at some product at this moment, till we get that carbon tagging on it, most of the expensive products which are there, they are coming far off and require a lot of metallurgy and other things associated with it, right? So then that becomes one of the important. Then once the product is entered into the space, now in order to fix it as well as to run it and give whatever is this product meant for you, so this is all your operationals count in. And then there is another leg of it is when I dispose it of. So then there's another leg of carbon which is going to be produced to actually get rid of it. So in case you got a product, for example, like asbestos initially was introduced as a green material to us. We introduced that into building fabric. Today we used it with a good life cycle, no problem. It was green product, it remained there, gave us a lot of operational goods also. But when now it is moving into the final stage of it, it becomes a hazardous waste. Now that is a relationship of material which you really need to think thoughtfully about it, because that has become a health hazard and as well as become an operational challenge to dispose it of in the way, because our technologies are very poor on that. So this is how, when we look at material, look at from all the three lenses of it, and that's how the selection goes.
Thank you. Yes.
In all the discussion that we had since the morning, there's a very negligible talk about the market. So let me give you a market perspective. We got funding from a CSR fund for an NGO construction of 1.5 lakh square feet, and they bought the plot, which was 7 lakhs at the outskirts of NCR. Now, we were supposedly given a guidance that it would be a sustainable construction without cement and steel. And so the options that were looked at in terms of the building blocks and no bricks, so it was either adobe bricks, which were solar heated or sun dried adobe bricks, or these blocks that use lime. Those were the two options. And for the roofs, it was supposed to be shallow domes. And there are quite a few people, I think Mohak, you would know about that. So in this whole discussion since the morning, there's look at the market. We've been struggling for 1 year to get somebody. We've got the budget, which is CSR funding. We've reached out to multiple institutes, and that's why I came for this event, to really get to know how do we take it forward. And in terms of the cost, as we look at conventional construction costs, if you could share, because there have been a few that you've given examples that proof of concepts that would really get to be done, So here we've been told that this is available. You can do such construction. There are a few architects who are inspired by DD Contractor and Laurie Baker. So, but if you could give some guidance, and Dr. Garade, you talked about how you've done a lot of work. So in terms of options or what it could be, and just both of you give us some kind of market estimate per square foot. Like today, if you go to a builder and say regular construction, they say 2,500 rupees a square foot. So if you're doing 1.5 lakh, just do the math, right? So give us an indication in terms of options and some kind of budget estimate or a market estimate.
So it's like objectively speaking, it would be difficult to be able to give a figure to it. But the fact is that the reason why you don't see a lot of these products in the market currently is because the demand is so low, and therefore there is such a dearth of skilled workforce, skilled artisans who can actually work with all of these technologies. You mentioned Didi Contractor, and therefore in Himachal, around Didi Contractor's campus and other places, you have some local contractors who are well versed with making Adobe bricks and using them in buildings. There are some established practices. For example, in Bangalore, you have Biome by Chitra Vishwanath, people who have actually been able to use compressed earth blocks commercially and very well. They might be better people to give you cost estimates, but when you talk about something like a shallow dome, those become very niche practices that only there are very few artisans and very few institutions also supporting those artisans. And therefore, from that perspective, those costs may, in some technology cases, maybe in the case of a shallow dome, if it's considered a niche design intervention, it may have a higher cost, although it's tough to say offhand, but at the same time, because the combination of materials is so different, in a shallow dome, you're not using steel, you're using very little cement, so therefore material costs are likely to go down, but labor costs are likely to go up, which in a way is a good thing, because I mean, there's more room for supporting local artisans and masons. But in terms of technology mainstreaming, there are very few people in the market who are actually demanding those technologies, and therefore a lot of those construction styles are also confined to very, very niche applications in particular projects. And which is why in some cases the cost economics may not be as beneficial as one would want. We'd be very happy to have you over at the DA building, because I mean, when you talk shallow domes, our building employs a few, like a lot of large spaces, large span spaces have utilized shallow domes and ferroconcrete channels and filler slabs and such. So I mean, there are proof of concepts in commercial spaces, like I mentioned at the DA building itself, and including compressed earth blocks and fly ash bricks and so on. For Adobe bricks, I mentioned for earthen-based architecture, I think there are some of these good architectural practices like Biome, like Hunarshala, which has supported so many local artisans and masons. There are upcoming developments now. We know for a fact that there are developments outside of Jaipur and many in Bangalore region as well, which are trying to sort of utilize these materials in large scale construction, not niche projects. So I think for specific technologies, you will find applications around the country which are more specific to that context, and I mean, I'd be happy to have a follow-up conversation to discuss more on this as well.
So I just want to add, while this corona was there, the workers moved back and reverse migration happened. That's the time when CSC has done one project, and there are 2 compendiums which are there on our website called Wisdom to Build, that actually takes care of the traditional technologies which has been used in multiple states. We in fact conducted a survey, as you mentioned, all these doubts were there, like in our mind, that people really want traditional material or not, and what are the hiccups which they have. So it's 500 respondents who responded to us saying that they want this, but unfortunately they don't know who are the people who are actually doing this, what cost is there, how exactly the building look like also. The dashboards were being prepared for it. So the interesting component under that is what we found is when the government started tagging these materials as kacha, so slowly the skilled manpower has moved away from it, because they don't get that requisite amount of per day cost which a skilled or certified technology could actually give it to them. So many of the states, I think one of the very good document is Pehel's document, which was initially for affordable housing. If you get that from internet, just look at it. It's very well written and has a lot of technologies embedded under that. And in fact, in case you get a chance, just look at this Wisdom to Build.
Thank you. Sir, 1 minute to wrap up your thoughts.
Actually, he raised a very valid questions, and replying in 1 minute is won't be possible, because you know you have asked for the alternatives and those things. So there is no dearth of knowledge and this thing. You see the development. Like Portland cement was invented around 1812. Then there was steel, and then there came RCC structures. So why this got popularized? Because the speed of construction, the desired shape and this thing you can mold with, right? So, and our structures got walls and all elements got thinner and thinner and thinner. What happened with that? Our thermal comfort was compromised badly. The very bad example is our tunnel form construction. You can see that the occupants are not accepting those kind of buildings because it gets heated up. Now, before 1812, if you see the construction practice, that was more sustainable. So, what was happening? We are using stones, lime, and that kind of material, or timber. Timber is also very badly treated in this country because CPWD put ban in 1990 around this thing because of deforestation. And now with the realization that if you replant, the most green material is timber. If you with the plant with systematic plantation in those things, most green material is timber. It's a ease to use with that and those things. So, okay, timber we leave aside. Now come to the stone, lime, and bricks and those things. Older this thing, mud bricks and those things we can say. So what was happening? That time everything was put under compression, not in tension. Because the invention of steel, we got a lot of tension, and we created tension also. Okay. So now with those buildings, the walls were quite thick, and the roof was mostly domes. So because everything was construction, so you can see there they were not needing any electricity or any energy and this thing maintained. And still, if you go to the older structures, you will find more comfortable environment inside those buildings. So now the solution, if we anything we give, that's a slower, and we need speed. But with modern technique, we have their drawbacks. That's where the problem is. Otherwise, we have so many solutions. Okay,
Thank you, sir. Thank you. And we have to move forward with the next round, which is on operational carbon. That's also an important component of the whole life cycle carbon reduction strategies that we've been discussing since morning. So on this, we of course have done a bit of understanding of what's really possible, and we've broken down the strategies into different components. So if you look at design-based interventions, which is basically how do you optimize building design itself through passive design or through considerations as far as orientation is concerned. There is a lot of work which has happened in this area, particularly on passive design for specific types of building typologies. So if you look at affordable housing, there has been work by both GIZ and GHTC. GKSPL and CEPT University have also come up with a sort of a compendium on thermal performance of walling materials and technologies. AEEE has been doing a lot of work on guidelines for passive design and affordable housing. CSE, of course, has been doing this work for a long time, looking at case studies, particularly on passive cooling, which is extremely important to create the knowledge base for the adoption and application of these technologies. If you look at appliance-based interventions, there have been programs and initiatives targeting the market penetration of super efficient appliances, but also market studies which have looked at specific products and what it would take to scale these technologies. So for example, CLASP had recently done a market assessment on air-cooled chillers and water-cooled chillers and how that could be promoted through the SNL program and what is the market adoption going to look like. Similarly, other CSOs and think tanks have been working on the space of understanding public perception, adoption on energy efficient ceiling fans, etc. Use of low GWP refrigerant based cooling systems. We have a gentleman from Carrier Corporation here who could probably speak a bit to it, but given the commitments under the Montreal Protocol, what has been the promotion of not in kind cooling technologies, we are looking at some momentum around district cooling in India with guidelines coming out from the BE side in collaboration with AEEE and GIZ. There has been some work being done on testing and performance assessments of technologies like gradient cooling. CSE has been, of course, doing work on looking at various buildings and their cooling energy requirements. A very excellent compendium has been produced by CSE, looking at some live examples of alternative cooling mechanisms deployed in the country, looking at some case studies in different cities, something of a resource which I would recommend everyone takes a look at. Further optimization, again through smart controls, digital tools, what all is available. There has been ongoing work in the academic side, looking at smart automation, load monitoring. Smart Joules is here. They can talk a bit about energy saving algorithms that they have implemented for their clients to get the most out of their efficient appliances and equipment. And if you look at just, continuously tracking performance, because especially with existing buildings, how do we really continue to improve upon operational efficiency? That is where benchmarking comes into picture, and few organizations in the last couple of years have tried to bridge this data gap. There was a big gap in our understanding when it came to the performance of buildings across different climate zones. So there has been some effort done by us, done by PS Collective, looking at benchmarking of different types of buildings, and I had showed an example of AEEE's work for hospital buildings. And finally, when we look at what users really would and how would they adopt a certain technology, we're looking at behavior change programs, and there has been some research on the academic side but also on the practitioner side, and trying to understand how people interact with systems and what kind of nudges could be given to consumers on changing their operational energy use. And lastly, as we discussed, clean energy is going to be a big part of it. If we look at decarbonizing the operational energy, and there has been, I would say, in the last 3-4 years, a big push on electrification, particularly of cooking. Large programs and initiatives being launched to promote electric cook stoves, some market studies being done on perception of electric cook stoves and how they would sort of sync with the Indian society, and some efforts on the RE-enabled appliances and systems, where there has been some work by MNRE to look at how building integrated solar PV is going to look like. We know of examples of one or two odd buildings doing BIPV, but what will it take to take it at scale? Do we take it for certain types of buildings? At what stage? And how do they really play out from the supply side? And there are, of course, other institutions like CSIR who are looking at R&D on innovative building envelope solutions and integrating the PV, which is again same BIPV on these sorts of systems. So these are our key discussants for the operational energy round, and I am going to just quickly go over their names. So we have Mr. Soumya Garnayak, Country Representative GGGI. We have Ashu Dehadani, who is the Director of Technical Development at GBCI, which stands for the Green Buildings Corporation Certification Incorporated. We have Abhishek, who is working at Smart Joules on cooling solutions. We have Pratima Vashan, Senior Expert at AEEE, and we have Mr. Shiv Kumar Batra, who leads the global product management at Carrier Corporation. I would invite my colleagues Tilan Subramanian, who's from WRI-India, and my colleague Fairuz Lutfi, who has flown all the way from WRI Mexico, not for this meeting, but for other things also. But she'll also be co-facilitating along with Dylan. And just a request to our key discussants here, given that you have seen the discussions on embodied carbon, I'm sure, given your interactions with this space, you have had opportunities to also reflect on embodied carbon. So you can talk about, of course, the operational part of it from where you come from. But if there's anything that you would like to highlight on the embodied carbon side, please do. And I think given the time, we might just have only one round of observations. So you can take probably 10 minutes each to sort of reflect on these questions. But I'll just put the questions out here and leave my colleagues to do the Q&A.
Thank you. So a pleasure to be facilitating this discussion today. I see in Mexico we have similar challenges, and also that's why WRI-India, WRI Mexico teams, we are implementing an all-in for a net zero built environment project, looking at national roadmaps, city action plans, and pilot projects. So for this round, I will start with you, Pratima. Nice to meet you. You have extensive experience, we know, in decarbonization projects across regions, also national building codes, city climate action plans, business case for municipal initiatives, and also including leading the analysis for informing nearly zero energy building standards in Ireland. So I would like to ask you, what are the best practices from other regions for building decarbonization that could be replicated in India? Additionally, what are the research gaps in India that may hinder the adoption of these best practices? And please, considering also your experience, if you would like to add around like operational and embodied carbon, please do.
Thank you. Thank you for that introduction. Just a brief introduction to AEEE. I think most of you here probably are familiar with the organization. AEEE Alliance for an Energy Efficient Economy works on and enables data-driven and evidence-based policies and research. Built environment is a key focus area for AEEE, and in that space it's been working on operational carbon, embodied carbon and energy, and increasingly on heat stress and thermal comfort, because as we've been discussing here, all of these aspects needs to be thought about holistically. They're cross-cutting issues if we have to decarbonize the building sector in the country. I think one of the things which we know there is a clear trajectory, it's been presented here, that with the direction we're going, we are clearly locking in inefficiencies, we're locking in climate risks into our assets, into our buildings, our real estate. And we're just deferring the cost liability for future. If we continue on this path, we probably face a huge risk in terms of tackling some of the problems that will emerge in the future with climate change as well. So just reflecting on, in terms of what is happening globally as well, I think the technological answers are very, very local, in which some of the panelists here have been talking about all the great research and the work that is happening. I would talk about 3 points that I think, and they're not necessarily technological. One of the things that I think possibly we could focus on talking more about, probably that needs a lot more bringing together different pieces of research as well, is talking about the cost of inaction. There is too much talk about the cost of action. What is the cost of inaction? Because if you look at internationally as well, as part of any cost-benefit analysis, there's often a social cost-benefit analysis before any policy is introduced, and often it would have a do-nothing scenario. So we are already doing do-nothing scenario in a lot of aspects, not everything. I'm not saying everything we're doing is not in the right direction, but the general trends we are seeing are not taking us in, they're taking sort of away sometimes from where we want to be. So I think that's certainly an area that we probably could focus on together as a community, bringing different pieces of research, because they'll talk about the impacts on productivity of poor thermal comfort, the impacts on health, on GDP, on energy security. There are a lot of different aspects to it, and that all comes at a cost to the country. I just want to reflect on one of the things that were presented earlier about the split between embodied and operational for affordable housing. And we know even that embodied carbon, we can't be sure that after we've got the thermal comfort in that home. So the moment the standard of living goes up, we're going to see cooling being retrofitted, probably inefficient systems being retrofitted because we haven't thought about them at this stage. So that's the risk we are sort of living with. The other point I want to talk about is we need to come up with performance metrics and best practice benchmarks across thermal comfort, embodied carbon and operational carbon, covering the range of climates we've got, covering the range of typologies we've got, because that's where the decision making at the asset level will become easier. We talked about a lot of the technology answers. Those decisions often happen at the asset level, but we need a wider ecosystem to be able to help facilitate that. So one of the things internationally, especially if we look at EU, the European Performance for Buildings Directive introduces a concept of cost optimal. It's not cost effectiveness, quite, it's cost optimal. So what it's saying is that each of the countries can develop their own standards as long as they're cost optimal. And that means that the energy performance, that's the energy performance level that delivers the lowest cost option over the economic life of the building. So irrespective of the fact that we have split incentives in the industry because, you know, somebody's developing, somebody's renting or buying, if as a society we think that energy performance level delivers the lowest cost, the lowest economic and social cost for the country, that's the level we need to aim for. That's the best practice standard we aim for. And the last point I'd come to is we might be setting those standards, but they are based on current technologies current supply chains we've got, current innovation skills, and whatever else, the wider ecosystem we've got. So we want to nudge that ecosystem as well. And there's been work happening on developing a roadmap for the building sector, but what we really need is a more granular roadmap for the building sector over the next decade or so that helps to capture where the innovation needs to focus on. And one of those aspects surely is about the construction materials and techniques that we want to use. There might not be one answer. I think there was a mention here. It has to be lots of different answers that come into the picture depending on the availability of materials and skills. But that is what will impact operational energy. It will impact embodied carbon, and very importantly, it will mitigate heat stress for the most vulnerable and for our mass housing sector, which inevitably we're seeing the implications now. They're only going to get worse from here on. So I'll stop there. Thank you.
Thank you so much, Pratima, for sharing this, and also the cost of inaction, how this would be important, and also taking into account experiences from around the world of this important work that we need to do now. And I'll continue with you, Ashu. Nice to meet you too. And for this question, and also I would like to ask you about your reflections, taking into account your focus on cities and communities. Can you share with us some of a summary also of your work and gaps you are trying to address, as well as some challenges that you continue to face on scaling or deploying solutions?
Thank you. So I work with the Green Business Certification Inc. and the US Green Building Council, and we essentially, to put in one sentence, essentially develop quantitative and qualitative metrics for cities, communities, and buildings to evaluate their sustainability performance, which includes all the parameters from natural resources to quality of life, equity, materials. Decarbonization is a huge component of the same. In our work, we approach both embodied carbon and operational carbon holistically. It essentially, the main question which we are trying to answer since last, I would say, 2-3 years, is how do we sort of marry the work which is being done at a macro level and the work which is being done at a micro level together. So many buildings doing so many efforts to decarbonize themselves. How do we ensure that the communities where these buildings are located and the cities where the communities are located are learning from each other, and none of the efforts are happening in silo? They're working together to sort of amplify whatever work is being done. Now, so this is where actually the previous presentation, I really like the point on early stage decision making, early stage intervention. And that is what we try to do, that how executing integrated design decision making at the early stage when the project is being planned or designed, bringing all the diverse stakeholders sort of together so that they understand what they're doing, what are they targeting, where do they want to go. A couple of points to highlight on both embodied as well as operational carbon. We have dedicated sections and categories on embodied carbon where we look at what kind of material is being used, can that material be reduced, can an efficient material be used, can a recycled material be used, do we have materials which have established benchmarks, established third-party verifications behind them, EPDs and such. How are they going to dispose of the material? Recently, we've also included a lot of information, a lot of strategies on deconstruction, on designing for disassembly. One key component which I look at from cities aspect is policies and strategies. So whatever work is being done, it has to be supported from a top-bottom approach. So integrating sustainable procurement policies, which I think Dr. Ankita was talking about, ensuring that the city is developing an ecosystem where the buildings can go for these strategies in a productive and a positive manner. Couple of gaps and challenges which we have come across. First is, so we look at scope 1 and scope 2 when we look at GHG emissions, operational carbon. Scope 3 is still very elusive. So going ahead, we are trying to work on that and trying to see how we can bring that under the umbrella. We also have a lot of data, I would say, discrepancies. And I was really happy with the presentation. We tried to work with the research organization and see what kind of research is being done so that we can revise our benchmarks, we can sort of upgrade our thresholds. So really happy to see that a lot of work is being done. We also have to address the regional differences because we work around the globe. A lot of our communities, a lot of the upcoming new large-scale projects are in Middle East. So a lot of huge community projects with aero cities and industrial parks are coming up there. We also have existing cities in the US. We also have communities in China and Japan. So trying to honor the regional differences, but yet bringing them all together in a way that we don't lose out on any impactful action is one of the biggest challenge which we face. About the performance which was discussed in this presentation, we have an ARC platform, so we try to sort of collect data from projects in a dynamic platform where they feed in the data for how much is their GHG emissions, how much are they trying to reduce, how much is the renewable energy dependence, and they keep on updating it at an annual basis. So this data also helps us in refining our thresholds and sort of charting a better course to help support the projects. So with, I think I will stop here and then maybe we can take more questions. Yeah.
Thank you so much, Ashu. It's important also this exchange of experiences. I know your colleagues, Rebecca and Veronica from GBCI Americas region, so for sure we'll continue that conversation to know the importance of these initiatives. And I turn it to my colleague, Dylan.
Thank you. Thank you. Thank you, Fairuz. Am I audible? Yes. My question is to Karnaik sir. So yesterday, in one of the sessions, you talked about the importance of demand aggregation. Then how you also talked about the Ujala program, wherein you talked how important it is to incorporate financial models to make sure the upscaling of new technologies. And you also talked about how you managed to reduce the price of LED technology within 3 years span of time. So I wanted to understand from your experience working with BE and ESL on so what are the existing research challenges, research gaps, and other challenges perhaps exist in order to upscale not-in-kind technologies? We are in an age where we talk a lot more about cooling technologies, not-in-kind technologies, and all. So from your experience, what are the existing major challenges?
Thank you for the question. In fact, it's a pleasure to be here. Thanks WRI for this invitation. Great works what I heard from other panelists here on the embodied carbon part. And a lot of things are in the research stage, and probably that will be a very good signing point for all of us when we talk about the new buildings which are coming, going to be designed or going to be in place in the near future. Having said that, I spent quite a lot of time in Bureau of Energy Efficiency and Energy Efficiency Service Limited, and let me straight away jump into some of the large scale programs which it did in the building energy efficiency program. Probably you may be knowing that the building energy efficiency program is the very first program of Bureau or India, I can say, after the Energy Conservation Act came into place. It was in 2006, I remember, and then we had taken about 20 buildings in the country, but most of them were in Delhi, iconic buildings. Those are taken for energy audits and see that where is the opportunities for energy savings and all. At that point of time, the energy audit practice was not that stabilized or not that, in place. So what we see that, there was 30 to 35% of energy saving possibility was possible. But if you see over the last 10, 15 years, there have been a lot of changes in terms of policy interventions, in terms of business models, in terms of project implementation, etc., etc. The classic program which impacted the building energy efficiency program, which Sumedha also highlighted, is the appliance energy efficiency program. That is the standard and labeling program. But out of all these appliances, if you see, and considering the building in play in the context, the cooling applications became a paramount importance, because 60 to 70% of your energy consumption in the commercial building, officials building, and so also in even the domestic consumers, that goes into the cooling sector. If I take the example of Delhi, this year we clocked more than 7,000 megawatt, and I was told that about 62% of that was due to cooling load. So that's contributed a lot of energy consumption, so also the CO2 emissions. In ESL in 2018, that we designed a program, we call it super efficient air conditioning program under our building energy efficiency program. So that is actually we retrofitted. The idea was is to existing building, not for the new building, and that's a retrofit program. Retrofit program means just replace 3 appliances: the lights, ceiling fans, and air conditioners, ACs, and typically the split ACs. So that is where we did it in 10,400 number of buildings, including the service buildings in the railways, some 1,200 odd bank ATMs of ICICI Bank or so, and some of the associated buildings in the income tax offices, etc., etc. In this, what we see is that there is a challenge in this program. The program design, it was 100,000 initial procurement, then we went for the 50,000, if I remember it correctly. We got a small grant of $5 million from the Global Environment Facility, GEF, but that was not a grant altogether. That was the interest-free kind of, the cost of financing was not included in the overall project cost. We did this project, but the challenge what we faced is that 2 things. One, the approach which was adopted here to convince to the client that the energy saving is happening because we procured a super efficient AC. Even DCB also was sometime arguing with me, why are you calling it as a super efficient AC? We do not have that kind of definition. We said that, sir, this is 5-star, but whatever is the average 5-star, it is beyond that. So what was that? At that point of time, the average 5-star was ISER, Indian Seasonal Energy Efficiency Ratio, was 4.8, 2018. So we procured 5.4. Although it is 5-star, but it's beyond the 5-star. So we cannot tell it's 6-star, 7-star because of the, that kind of definition was not there. So technical, specification, finalization, and getting it supplied from the available technology providers was a challenge at that point of time. That's number 1. Number 2 is that the public procurement, which Dr. Ankita also highlighted, we struggled a lot. Public procurement means how we were actually doing, fixing these contractual obligations with the manufacturer, where also we wanted to put the low global warming potential refrigerant, less than 50, and that was another challenge. And he's talking about the research part. Then people were arguing, if you are going, why are you introducing low global warming potential? Will that be having any impact on the energy efficiency or not? That kind of research, but I was told that that kind of research has not been empirically proved that if we are going, having this low GWP refrigerant, how it is impacting to the energy efficiency or not. So the point is that from the supply side we struggled. The other one is that the most important thing which I also struggled in the point is the pre-dispatch inspection. Because when we are procuring 100,000, 150,000 number of air conditioners which are super efficient, and you are putting more than how 400 crores, roughly about 380, 300, 400 crores as the investment to it, it became a very necessary that whether you are getting a quality product or not. So the quality assurance check from the manufacturer side, from the warehouse, this is also extremely important. What we call it as a protocol for pre-dispatch inspection. Now coming back to the quantified energy saving, that kind of calculation was also not there. Calculation means it was a deemed saving approach. The base AC was, air conditioner was 3-star. Now I am having a 5-star or a super efficient AC. Both difference multiplied by the number of hours of operation, everything on assumption. So that is where, we tried to convince to the clients, because most of the clients are government buildings and all. I'm not going into the how we convince to the Ministry of Finance to give a different, guideline to the building owners to go for this model or no. Let's not go into that. But the point here is that how you convince to the finance people in the building owner or the building owner that they are going to save the energy. The next question is that, please show me whether you are getting this kind of saving or not. So my point here is that getting a good protocol on the actual energy saving, whether it is a sensor based measurement or whether it is a on-site sample based measurement, that has to be. The deemed saving approach was, although we did it, because ESL has that, market push penetration power to do that, but it was not a kind of, because I was the program manager, but I was not happy the way it went, because you cannot convince to that part. The next one I will stop after this point is that we also tried to do it with the utility scale DSM programs. Ladies and gentlemen, let me just highlight you, the distribution companies, they are the major hit points for this air conditioning load. They experience a peak load during their day, and that is where they become very, very vulnerable to the high power purchase cost. And that power purchase cost impact to the entire thing. And also because of that 4-5 hours of peak load, their supply power infrastructure is also under a tremendous pressure. So these are other parts. The point here is that how this air conditioning or a super efficient program can actually impact to a demand aggregation facility, facilitate the demand aggregation as well as reduce the peak load of the discoms. That is what we did. In Delhi also we did, I also supported the Tata Power BSES here in 2019, 2020, and that was the point here is that where we, because of the peak demand reduction, the benefit, the monetary benefit which is the utility is getting, how that can be passed on to the consumer. So it's a business model. So that means if I am telling that you go for 5-star, you will reduce the energy efficiency, the next question is that 5-star is costly, I cannot do that. So that means the point is that if the 5-star AC or the super efficient air conditioner, can that be made available to a cost of 3-star? Then there is a business model. Then how is that gap is there? One is the bulk procurement. We got a reduction of about 23% price from the retail market. The next one is a buyback policy. So you get about 2,500 if you are replacing an older AC. The third one is the benefit or the kind of incentive that can be made through the this one, which is from the utility through this reduction in the power point, what is that peak demand reduction. The most important which we did another model in Maharashtra and Gujarat is that the on-bill financing model. That is where if the AC is charging, costing about 40,000 rupees, but the industry, the consumer, the building owner, he has to pay in, say, 40 installments, 30 installments. That we build onto the project cost. And that installment, monthly installments or quarterly installments, that can be paid to the investor or the service provider. Here it was ESL. But I cannot go to the building just to collect his money, raising an invoice every month. So what we did, we took the utility into the picture, where utility will take that in their electricity bill. And from that electricity bill, because this is the additional cost, and that cost was paid back to ESL. That was a quite successful model, but that was a challenge to that. In the interest of time, I am not touching upon that. But these are the kind of, the business models, getting a demand aggregation in view, everything. I think the other points which I was listening to the points to other gentlemen, what they were saying is also, for the embedded carbon, unless otherwise a demand is created, nothing is going to happen to that. That you require policy, you require a lot of other dots to be connected. But the cross-cutting technologies which are coming up, apart from this normal conventional AC technologies, particularly the district cooling system, the tri-generation system, which are categorically mentioned in the Indian Cooling Action Plan, that also needs to be taken care of. But time is short, I'm not going in to highlight all these things. Probably I'll be happy to discuss with anybody offline. Thank you very much.
Actually, I was about to ask you regarding the district cooling and the cross-cutting technologies, but thank you for highlighting the different business models, the importance of business models in mainstreaming these new technologies and all. And probably the point that you made, the research is required to understand whether low GWP refrigerants does have any sort of impact on energy efficiency. Perhaps the next person, Shiv Kumar Batra, is the right person to ask that question. He's from Carrier. So Shiv Kumar, so we have had this discussion earlier as well. Carrier was one of the 6 manufacturers who voluntarily participated in the standard and label program for water-cooled and air-cooled chillers. It was a very appreciable effort, I would say. But at the same time, when it comes to phase down of HFCs and all, which is going to be mandated pretty soon, what's your take on that? What are the existing research gaps and what are the existing challenges that Carrier foresee when it comes to implementing those measures?
Good afternoon, everyone, and first of all, thank you very much for giving the opportunity to come over and share my thoughts on this. So, when it comes to HFC phase out, or how to get it new refrigerant coming in, right? The 2 things which I can see is push and pull, which is required, right? Pull from the market that they need, and push from the government that okay, this has to be done. Unless both things happen, right? It is very difficult. Either you create a market which actually asks for that, okay, we need a low GWP refrigerant, right? For example, the customers coming like Microsoft, Google, they ask for it, but not everyone. But if it becomes a push from the government that, okay, from this state, this is going to be, then there is no choice. You have to do it. Then the second challenge, which is on the awareness and capacity building. Currently, if we talk about, right, even R22, right, people are using it up, right? People are using R10A, people are using R32, people are actually looking for R290 also for the same residential unit. So there is one thing which is the requirement, second thing which is the goal that you have. So if you have a sustainability goals, right, then you can look for the alternate solutions even for the refrigerant also and for the material also. But unless and until you have those things within your guidelines, okay, we have to do it. This is not going to work it out without the push from the government. So if there's a push from the government, there's the standards coming up from the government, okay, these are the standard even for the material, even for the HVAC equipment, right? You have to do it. Now the link between the refrigerant and efficiency is there, but again, it is not only a refrigerant which can actually drive the efficiency, right? So you have to define your efficiency goals separately and your refrigerant goals separately. So one is, which we talk about, even Dr. Sareen mentioned about it, 3 stages, right? Embedded carbon, right? For the HVAC product line, yes, it is there. How I'm manufacturing my product, right? What refrigerant I'm using it up. So that's the first stage. Second stage is how I'm using it up inside the building. What efficiency levels. We define 24 degrees C as a indoor room condition temperature. But why 24? Why not 26? Why not 28? Right? So this is something psychological. You can improve the efficiency of the product by just changing your thought process into it. Third thing is, once the end of the life comes up, what we call is, okay, let's say for a window air conditioning, it is something like 10 to 12 years. What happens after that? Those machines were dismantled and then they goes to the nearby market and then they are again sold into T3, T4 cities. So you are not actually reclaiming the refrigerant, neither you are removing the inefficient product from the marketplace, but you are relocating it from TR1 to TR4. This is not going to help, right? So we have to make a standard. Okay, there's a push from the government, that's fine, but we have to make an awareness at the tier 2, tier 3, tier 4 cities. It should not be only concentrated on only Delhi, Bombay, Bangalore. We are making good energy efficient, low carbon emission buildings, and rest of the India we are not talking about. So it has to be, across the regions. And to do so, we need awareness, capacity building, and to support it, we need a standard. So unless and until we have a very strong standard activity coming in, this is not going to, take it to the next level where we want to take it up. Right?
Thank you. In terms of research and capacities and development, where do carriers stand?
Okay, so for research, so there are 3 tiers, if you ask me, from the organization point of view. There are global companies who do their own research. They don't need any agencies or somebody to come and support them. They know how the market is going to be in 5 year, 10 year, 20 year down the line. So make the product available according to that part. But there are research which is required, and the teams are working on it. I'm sure the people might be knowing about the IIT Delhi, right? They have done the research for R290 refrigerant for an indoor unit. So they take the standard IEC 60335-240 and make it that whether this is rightly applicable for our conditions or not. So there is an association coming up. When it comes to government, there also the association is already there. So BIS works with planning to set up a SDO model, right, where they are inviting the I would not say third party, but yes, inviting the independent parties like Rama, ISHRE, right, to come on a board to define the standards, to write the standard for them, so that it can be go into a fast track. Now, normally what happens when it comes to the BIS, just a body, right, they have to do too many things. So if they have to develop a standard, it will take approximately 2 years time, and then its implementation will take time. Now, instead of that, they started a very good model which is to identify the SDO. So they will give an authority to some third party who will write the standard, give it to them, they approve it. So the process becomes faster. So fast tracking mode is required if we want to increase the speed. Otherwise, we have to wait for 4 years, 5 years to get a standard, and then its implementation. So we lose the bus over there, right? So we have to make sure that this process is much faster speed.
Thank you so much. In the interest of time, so we will have this discussion offline as well.
Sure.
So next, I will come to Abhishek. Sumedha has already presented your work. You are working on energy-saving algorithms and all, which is very much data-intensive process. So when it comes to research and process, and do you think any sort of data gaps exist in the demand side, which would have helped you to make your algorithms much better? So what's your take on that? And we would like to hear about the reflections on the strategies that we developed as well.
Yeah, thank you. Thank you, WRI, for inviting us, and a very valid question. So in terms of research, whatever we are doing is more of like we do an on-field implementation, whatever we do. So for example, when we thought of like implementing algorithms and going from standard, the process, or like say SOP of the operations, we thought let's have a machine learning, to get into our systems and start working on them. We initially thought whatever like is down in the market, that machine learning is very cloud intensive, you need a cloud and all. But then our team was able to crack down that how we can be like still into the machine learning, can have that onto our controller. And we try to like, break it in even like how to be less crowd intensive by we are just like doing a weekly, link up within our controllers. And, that's how like we just de-linked and make it very, very efficient in terms of, because if we will deploy some kind of systems which are like, cost operationally very much, it like, on the other end, when you give out to the clients, it will be not really saving that much to them and doesn't make the product sense. So that's what we done. So we did that implementation. For example, I'll just give you a very small example of the cooling tower automation, which is very much dependent on the load, very much dependent on the weather. If you just like feed in some very basic logics, then it will just keeps on working on that. But the machine algorithm, which we have put in, like you give that basic logic to it, and that it just keeps on learning over the time. The major data which goes onto the cloud, that becomes the history, and that like keeps on feeding back. Okay, like around 6 months back, this was the data. Now you can do this, and every week that keeps on happening. Now we are very much successful in doing that in terms of the plant side, which we say as in a production side. And because that's what the primarily things that we were doing. Now when we want to go on to the low side of the system, where we say like the consumer, where like it's your air handling unit, cassettes, or any kind of a thing, when we want to do that, we don't have actually really data available from the producers itself. Like, do they have your own product, how they react to certain different kind of BMS systems and all, that if we want to develop it. So when we are looking on that we have to do our own implementation, is again the same thing, that we need to have a small pilot for it, we need to do it, and then we say how did it works. Another thing to that is that we have to look as in the whole system itself. When an algorithm works, it works as in it gets a cookie is of like the efficiency. So right now it's working only on the plant level, that it's saying the cookie is like, the kilowatt per ton of the plant to be the best. Now the next challenge that we have with us is now how do you see an entire HVAC system, the kilowatt per ton of the entire HVAC system to be the cookie. And for that, like that's the challenge we have ahead of us. One of the things that we are looking again, what was like rightly said, is like the thermal comfort, right? We have to give to the client with the fixed temperatures. But what if we start looking at, even if like, for example, if you have an FCU inside the room, can we get it to a higher CFM or like a higher airflow and at the same time set it to 25? And that's what our algorithm like next process is. But to have that, we don't really have from somebody already that research available with us. So that's the challenge that we face now. So very soon, once we implement that, and like we'll have the answers for those. Thank you.
Thank you, Abhishek. So in the interest of time, I think we will have to open it for the audience. So any questions? Yes.
Hi, my question is to Ms. Ashu, GPCI. So now my name is Dr. Saurav Verma. I research on green buildings. So, certifications have various categories: energy, atmosphere, sustainable sites. And now the sustainability goals of the users are moving towards, scope 1 emissions, scope 2, scope 3, operational, how much embodied. So how can certifications represent more in terms of what scopes, emissions credits the users can get for their buildings? Because I think in terms of various categories, that's not very clear that what emissions, what credits are targeting what kind of emissions. So can we simplify, and what about alignment of these frameworks to some other frameworks which corporates are looking at, SBTI or some other frameworks what they are looking at, so that they can know, by having a green building, how it's supporting their broader corporate sustainability goals?
Thank you. So firstly, we continuously keep on working with these other frameworks. So like with SBTI, we also are working to align better with various ESG frameworks. Anything to essentially reduce the confusion and the workload of the projects which are choosing to go for choosing a green building rating program. So we try to find synergies with them. Second way, how we about the confusion, whether it's scope 1 or scope 2 or which kind of what is being addressed. As you might know that we are right now working on a V5 variant, so that's happening. So for cities and communities, we have just started the work on V5. So and that is one of the biggest component, that how do we make it simple to understand, and how do we make sure that people know that this is where this strategy which you're doing, where is it helping? It's making you more resilient, it's also helping you reduce embodied carbon, it's also say elevating your quality of life. So those sort of parallels and connections which make it easier to understand, we are trying to make it more, bring it to more to the forefront of essentially of whatever we're doing. Second, we also are looking at developing more resources, educational resources, and I think that is where all of the stakeholders can also be. This is a good forum to discuss how we can bring all the research together, which helps us inform the market and helps us inform the project better. Because when we look at scope 1 and scope 2 or even scope 3, there is just so much research already available. It's just about how to simplify it and make it more palatable for the projects, so that they understand that what steps are they taking and what more steps they can take. We also try to work with the projects when they just come for registration. So we do try to have sort of more meetings with them and guide them to these, nudge them to these different resources and different organizations who are doing this work. Yeah. Thank you.
Hello. I just want to know, is there any possibility of retrofitting the building itself? I mean, you talked about the retrofitting of the appliances. Is there any provision in the existing building how to retrofit for the, at the, being a resilient building in terms of energy And as well as for the building is concerned, we talk about designing and planning for the building stage. There are other aspects which, to make it a resilient building in terms of the earthquake and all. I mean, when we are talking about the energy efficiency building, we have to see in terms of either the earthquake resistance or not. So how we consider it, like we cannot talk earthquake resistance separately than the energy efficient building separately. The planning and designing of this for existing building and appliances for the, as you talk about the retrofitting of the appliances. The other thing I just like to know the consumer awareness about the application of the appliances, right? I mean, we use the AC, but again we use the AC blanket. I mean, it looks like, so this was on to, can somebody can comment on this?
So we do have a program for existing projects as well, which looks at retrofitting, which looks at how we can go about essentially improving an existing project. And we don't have specifically earthquake, but resilience planning is an important part of the program. So I would ask you to look at the Lead for Cities and Communities framework. So there's one credit which looks at resilience planning, where we ask the project to essentially identify that, what is the issue which they face in their region. It could be earthquake, for which they have to prepare. Like in case of an earthquake, what will happen to the building? How will they have an evacuation? What kind of systems will have to run? Sort of essentially having emergency preparedness from that angle. They can also identify any other issues which they might have. For example, someone in California, wildfire could be a threat to them. So in this, not directly, but we do have that embedded, where they can identify and then develop appropriate strategies for that.
Thank you. I think that's a absolutely relevant question for us, because although we are going to be in India building a lot of our building stock, we still have a good proportion that will still be standing now and in the coming years. And this brings us back to the fact that when we design buildings, we're designing them for 40, 50, 60 years. Appliances get replaced 15, 20 years. Yes, that's still a long time span, but it's a product that will be replaced 2 or 3 times. There'll be an opportunity to upgrade. There'll be an opportunity to exploit the innovation that's happening in the industry from Carrier, from other companies. And they also focus on that innovation. That's their business. But buildings are built every time with different design teams, and there is a time lag with our learning as well, applying the innovation that is happening and the research. So retrofitting is an option, but it comes at a cost. If you're able to design right from the beginning, we are able to not just think about the appliance rating, which has had good success in the country and there's still room for improvement, but we think about star rating of the building envelope in the first place. Are we building 1 star and putting 5-star ACs? We're losing a lot of opportunity there to do better, and for the whole system and our power grids to work in sync, because otherwise we have that challenge, as we were talking about, that peak demand, extreme heat waves, either people are suffering, they are having health impacts, there's impact on productivity, or we need to be designing for a peak load, and where's all that renewable energy going to come from? Retrofitting is also, it will need to happen and will need technologies for that, but it will often have a limited remit unless we are doing it at the point of, when it's a major renewal, like the windows are getting upgraded and you can do something with the fabric or retrofit insulation in it. Most other cases, and often what happens is we end up just working on the HVAC systems rather than in a holistic way when we're retrofitting. The marginal cost will invariably be much higher at that point.
Yeah, I may just highlight, I may just highlight what you said about the behavioral change, and that's very important, and that is what the mission life of Government of India talks about, the lifestyle for environment. So, but it is a continuous process, because it's a continuous engagement of the consumer and all. It cannot be on the overnight. It has to go on with different interventions. I mean, it is a learning or convincing to the consumer to go that. The other way is that how we can utilize the technology, particularly the automated things. If you are using, energy appliances in commercial buildings, government buildings, and all, where you can use the sensors or the gadgets to control your equipment. That's one part. The other one is that I was, discussing few days back with one gentleman from Oracle, and they had done a project with BSES Rajdhani, if I am not wrong, where they are, all the consumer data which, the Discom, they supplied to them, and they have a tools, analytical tools which use that particular data to say to the consumer that you are losing money here if you just change your appliance use from this time to this time. That can be done. But if you see, this is also linkage to the time of day tariff of the domestic consumers. Unless otherwise that not there, why I should be tempted to use my air conditioners in the off-peak period, or maybe the off-peak period, or maybe any other appliances. So it's a link between, the policy things which are coming from the tariff perspective. So that means you are tempting to the people to shift from your usage from your peak demand to the off-peak time. The other one is usage of the gadgets and all, but of course it will increase the cost. The third thing is that behavioral change, which is a continuous process, it has to go on. So it's an involvement of all the people who are using the energy sources.
I think one step has already taken in this technological grant, innovation grant money which Government of India gives to the existing housing, because after this thermal comfort for all 2019 regulation India cooling action plan, so there is amount of 1 or 2 lakh which is given per house, where they can change their windows, they can change their materials and all. So that's there, but largely support is coming for housing in that case. So retrofit the existing housing, so that at least they remain and for a longer duration rather than becoming a dump yard later on.
Sorry, I just wanted to touch on the last point that you were talking about, where you're talking about earthquake and that thing. One way that I look at it is, I don't know, do we have structural engineers in the room? I mean, we need to. You are a structural engineer.
Sorry, I'm not, but we've been looking at some of the disaster resilience and the impact on operational and embodied as well.
So basically, one way, if I have to put in the whole, what you said about earthquake and what we are working on embodied carbon thing, because we are talking about material efficiencies also. One of the few things that, when you say low design intervention for low embodied carbon, material intervention, which means concrete and steel mainly. So first, obviously, no structural engineer will tell you, okay, less or, will compromise on the earthquake safety. So one, again, since I'm not a structural engineer, I won't be able to tell more about it. But the thing is that that's where structural engineers will start from, the earthquake, seismic load, or the wind design, or wind loads and all of that. And then there needs to be a lot more, looking at multiple designs at various levels to see what is the material efficiency that come out at different, for example, for operational carbon, we have different climate zones. Maybe the embodied carbon, concrete and steel can be looked at in terms of different seismic zones and different wind zones. If we do more and more, look at more and more buildings and look and see what kind of construction technology comes up with what kind of numbers, like per meter, meter cube concrete per meter square or something of that sort, probably, we can come to a link of, what gives an earthquake safe design and what will be good for embodied carbon. But first, the earthquake thing is always taken care of first. And
in the interest of time, we will have to stop. So all these experts will be here. If you can ask offline, that would be great. So to give the closing remarks, I would request Roxana, who is the global lead, built environment. She'll be giving the closing remarks for this session.
Hello, everyone, and wow, what a discussion we've had. I want to thank each and every one of you, the participants that joined us today. We've had a very enriching discussion. We've had, esteemed participants from various organizations, and we all gathered here to learn from each other, and I hope that we have at least scratched the surface of what we could learn from each other and how we can take kind of these conversations further. We gathered as representatives of industry, of different, building sector, kind of civil society, academic and other research institutions. And we were here kind of united in finding a way to really contribute towards the India mission and target to work towards kind of taking pathways for scaling decarbonization, the roadmap that we have heard needs further granularity in the sector, but we must do it at speed and scale, and these are the key parameters we really need to reach the level of ambition that we heard from yesterday, that India has set in terms of the targets to put us back on a 1.5 degree pathway or as close as possible. And our team laid out the sector decarbonization pathways modeled by some of you and some of the representatives we had, by CSTEP and others. The initiatives, again, that you spoke of to decarbonize the building sector in India and to address the whole life cycle, embodied and operational carbon strategies. So for embodied carbon, we highlighted kind of the improved building design to begin with, the construction practices and the production procurement, the use of the low carbon materials, and many of these strategies we know have an application for end-of-life reduction as well. To reduce operational carbon, we stressed again that we need to look into kind of the holistic approaches here, looking into behavioral policies, the energy efficiency of appliances, and clean energy procurement as well. So this is what we set out to do. This is what we highlighted by our colleagues in the beginning. What we heard from our respondents has been just a wealth of information that we'll of course share further. So I will attempt to summarize, and bear with me as there is a lot of ground that we covered today, and there will be an opportunity for us, and I think a huge kind of desire and impetus for us to take this conversation further. But in response to some of these strategies that the team highlighted in the beginning of each of the sessions in these kind of scene-setting presentations, we heard from you, from our esteemed speakers, unanimously that you're all working hard to make these strategies really happen on the ground and across the sector's value chain. So we agree that in order to achieve those decarbonization goals, a whole life cycle carbon approach is needed. And we've had enriching discussions that have focused kind of in each round. Firstly, very much so, I think we've heard that over and over again, on the importance and the focus that needs to be on the design stage, where the largest abatement potential lies, and at the same time, balancing that with addressing kind of continuingly the efficiency side of the equation. But we know that buildings must be designed to capture the heat and most importantly the coolness available in nature, and that we are all very much aware of in this climate. And the first stage of planning and design really costs nothing. It is design focused. Efficiency, on the other hand, is still less affordable in some instances, and this is something that we must address in a more kind of equitable distribution of resources way. The panel yesterday, just drawing a parallel, we had a discussion around kind of equitable transition in the energy sector, and the benefits of kind of energy efficiency and energy security via kind of a renewable energy pathway must be reaped by all, and it is something that we're still grappling with so that it isn't just affordable to some. But when it comes to cooling and thermal comfort, we heard today that technical specifications and supply-side incentives are very, very necessary. And on the other hand, as well, we had several references to public procurement, especially from a QA, from a quality assurance perspective, and highlighting kind of the importance to develop several types of protocols and de-risking for investors in particular, such as creating opportunities for demand aggregation and peak demand reduction. So these are business models that will help kind of mainstream some of these approaches, the technologies, and most importantly, to address the equity element and bring energy savings to all. There are, however, lots of challenges, lots of gaps in the market in the design phase, especially. So we heard about the lack of skilled workforce, especially in the prefabrication housing, in order for that to take off. It ties to designing on a large scale, at community, neighborhood, and at city level. So how do we design our buildings within the city so we don't exceed the carbon budget of the city? Integrated design really requires more of a built environment, so that's infrastructure, buildings, places in between approach rather than a building-specific strategy necessarily. So there are context and location and kind of regionally specific considerations that we heard that we must take into account, but learning from global perspective and global best practice while honoring these regional and context-specific differences will be key. On the industrial decarbonization challenges, we heard about lack of standards for low-carbon cement and steel, and aluminum as well, lack of incentives for green procurement again, the fragmentation of the building industry was a recurring theme, and no clear kind of low LCA that defines the level of kind of the cement and concrete that are needed, and lack of awareness. Academics are in this room as well, and other practitioners are trying to address this, but still very much in a piloting stage, and this is something that needs more mainstreaming, scaling support. And the difficulty is this lack of market acceptance of these other alternatives that exist from kind of a more testing experimental stage, and the profit margins is something that, the competition of cost is something that needs to be addressed. So what can we learn from other geographies that have established some of these policies in place to scale the technology? So ambitious targets are good, definitely a great start, like we've heard in California, but not enough. So we do need more of a long-term plan. We have other options to decarbonize, those hard-to-abate materials, and we need that market acceptance in public procurement. And it is really true that the governments can only regulate what they know. So the best performance standard existing in the market, and this applies to decarbonizing the hard-to-abate materials, as well as for the operational carbon reduction strategies and technologies that we discussed, that needs to be there in order for the government to regulate it. It works both ways. We need the technologies, the experimentation, the kind of the best performances to continue to outdo themselves, but we also need the government to set kind of the right regulatory pathways. And we heard also about kind of the supply chain management that is needed to kind of manage the mainstreaming of production of these building materials. Similarly, for end of life, when there are regulations and policy mandates, decision makers at the local level that are closer to the ground, working on these challenges are often working based off of the old assumptions or methodologies or baselines that need an update. So this is something that we can all help to address, and we are working and creating strides in this direction. The data, the assumptions, the recommendations need to continuously update, and it wasn't the case, for example, until very recently, but in some places in Western Europe, there are now marketplaces to create the reuse of construction materials with the existing storage facilities, insurance provided for the reclaimed materials, and also kind of refurbishment opportunities. So circularity is seen as a means to an end rather than the objective and the goal, and it's something that we can continue to improve and learn from. On the resource consumption side of things, so we talked about the materials decarbonization, but I think, going back to the design stage and resources, the need to intensively use secondary materials and to include kind of reuse, recycle strategies, designing for disassembly, broadening the use of kind of, vernacular building materials. And as we heard again from the Honorable Secretary of the Ministry of New and Renewable Energy yesterday, Shri Bhupender Bala, he said in his recorded address that the priority for the government of India is using minimal resources while maximizing what we have. And this is a key to achieving sustainable development. This is very much something that we are advocating for. And using kind of the various nature-based materials, avoiding the synthetic ones is something, with the toxicity levels, is something that we had kicked off our conversation about as well. So we heard about that organic material integration into cement to reduce the density, to increase the thermal conductivity. But how do we create really the markets for all of those examples of existing technologies that are still very much in an experimental phase? So demand, creating the demand in the market is absolutely key. And the field needs to continue to test, experiment, and incentives need to be there so that developers, architects, and those deciding on what materials are to be enabled and used, and they feel empowered to choose the sustainable option. Lack of standards and certification is something that seems like it could be a low-hanging fruit for these materials in order to be mainstreamed, to be addressed. So this includes both kind of a lack of standardized, uniform, and simple standard, for lack of a better word, but across the board, that's something that aligns to other frameworks, as we've heard now in the Q&A. And likewise, technology transfer is absolutely key, whether using software such as AI or hardware through kind of the manufacturing. Brick manufacturing is something that we discussed as well. Compare it, kind of, the embodied carbon of various different options is key so that we can make most informed decisions, cross data kind of comparison, categorization, and to work towards kind of data benchmarking and typologies for buildings to find those custom solutions. Several of the discussants mentioned work on affordable housing and how the building typologies need specific solutions. So this is something that we really need to address from a kind of a field perspective as well. We also heard about the cost of inaction from social, environmental, and of course economic standpoint, focusing very much on the people experience, as thermal comfort is something that we all experience, and especially the ones that are most disproportionately affected by the decisions that we make. So creating, cost optimums, following again examples from other countries, and giving flexibility as long as we can prove that these are informed business decisions. Could this help us create the market that we need, and to ensure we're not focusing on just the tier 1 cities where the experimentation happens and pushing down the new solutions and technologies to them, but to make sure that everyone really benefits. Finally, collaboration. So we stressed, of course, the need for collaboration in the market and for these public-private partnerships in order to incentivize continuation of innovation and experimentation. Understanding and meeting all of the stakeholders halfway, understanding their priorities and how they prioritize working at speed, and additionally cities and communities and practitioners learning from each other's efforts, especially during these early stage design kind of interventions with bottom-up community engagement, seeing the problems from kind of a more systems perspective that could be addressed. So where does that take us next? So we have discussed and we have learned from each other, and that globally innovation in this sector is quite challenging. The life cycle of buildings, from the construction to decommissioning, is a major consumer of energy and resources and will continue to do so, and yet the level of innovation remains low, or at least it's mainstreaming. And we hope we shape the discussion heavily geared towards kind of mitigation measures and kind of the work that can be done, and on the design side, focusing on adaptation. So I'm really curious to see how we can continue to focus the discussion, kind of that adaptation focus, with passive design into the mainstream, and so that we don't repeat the same mistakes over relying on hard-to-abate building materials. And indeed, India's mandate for kind of locally born, locally produced solutions in the sector and in the value chain as well can offer an opportunity to innovate and leapfrog. So given the fragmented nature of the sector and how technology update is relatively slow still, as we've heard, there's an even bigger need for multi-stakeholder collaboration, as we just mentioned. There are ways to address kind of the policy and regulation, the research and data, the capacity building, and the financing side of things, so we hope to continue this conversation. We look for ways to incentivize behavior change as well in our work and through kind of our communities of practice. Incentives and nudges are needed over a longer time frame, so that isn't only kind of a market failure, again, making a reference to the conversation we had yesterday, focusing on kind of asymmetric information on the demand and supply side, but really from kind of economics point of view, we need incentives. And context as well really matters, so that whatever we design, it's built to withstand whatever climate risks and natural disasters, to name a few extreme cases we are aware of. And as this is a roundtable on decarbonizing India's building sector for the future, we need to plan for what comes next and for the future we want. So this is part one of, we hope, at least two-part series of convenings of experts such as yourselves and practitioners to help us advance India's lofty goals of decarbonizing the sector in a whole life cycle way. And a summary of the roundtable deliberations to inform the market, as one of our panelists just mentioned, it's something that we seek to continue to do, will be produced as part of the ACE 2024 event report, and my colleagues will be in touch with all of you with copies, but we hope to continue the discussion further in our next gathering organized by WRI-India in September at Connect Cairo. So thank you again. We really appreciate your time and your valuable contributions and partnerships. We hope to see you soon, and I will be handing over to my colleagues now to do the wrap-up of the event. So thank you for staying with us.
Thanks, everyone. As we come to the end of the 5th edition of ACE 2024, I would like to invite my colleague, Deepak Sriramkrishnan from WRI-India to give us the closing remarks.
Hi, everyone. Good afternoon. This is the very difficult task of summarizing 1.5 days, and Roxana, if you took 10 minutes, I should hold you all for half an hour, but no, I won't. I think firstly, thank you everyone for taking time out and spending a day and a half with us. I think the familiar refrain about the energy or the electricity sector is that if Thomas Alva Edison were to come back from the grave, he wouldn't find anything substantially different. But I think he will find that, the system that he had designed and thought about, and of course, lots of others have contributed, is actually doing a lot more than what it was originally designed for, and doing many different things. So I think a more appropriate example to give would be, I'll again dig into the Marvel universe for this. Victor Timely. So also recommend that you try and watch Loki, the series on Hotstar. Maybe that's a more appropriate context for me. So I think from the first ACE back in 2015, where we were only looking at, in fact, we had the entire discussion on just two very specific topics, looking at procurement of renewable energy by commercial and industrial consumers and water consumption by thermal power plants, to now we are looking at an overall people, climate, nature framing. It's quite a long way. And it's also seeing a lot of this reflected in the ecosystem in terms of research that stakeholders are undertaking, government priorities. So I think that's a change that we have also observed, and it's quite encouraging, and look forward to more of this. We had, a good context setting in the inaugural, where the different speakers spoke about the imperative for the energy transition, India's role in it, and also new areas that needed to be looked at, namely critical minerals, for instance. And from there, we moved to the energy transition for all session, where we heard perspectives on how the JETP, that is the Just Energy Transition Partnership, how it is playing out in South Africa, how things need to be customized for the specific country context. And we also heard, very importantly, that even though we are thinking about all these new innovations, transaction costs remain high for the poorer, and less privileged, citizens and consumers, and that's where the importance of planning to ensure that no one is left behind. There was also a particular remark about how we are looking at everything from a very engineering point of view. Very true that the engineering has kind of become very siloed into very just technical specializations. But again, literature has some hope for us engineers. So Alexander Solzhenitsyn in the Gulag Archipelago of all books says that, how he was inspired by the agility and breadth of thought of the engineers of the 1920s, yes, 100 years back, but definitely we can bring that back again. And he specifically talks about how they shifted from one engineering field to another, and from technology to social concerns and art. I think that's the spirit which we need to bring into this energy transition so that it becomes an all-inclusive perspectives. We had a very engaging session looking at challenges and opportunities. We covered infrastructure issues related to land, how solutions need to be designed to the local context, interconnected issues, planning in an uncertain scenario, and also institutional alignment where you need to follow up to very obscure corners of tender documents, maybe page 211 subpoint 7a, something of those. Though that is the kind of depth and intricacies that you need to resolve to get the a transition going. We then also had a deep dive into the world of technologies, and I think even today we touched a little bit on construction, energy efficiency, etc. I think the idea is that we also need these demand side technologies to become as prominent as the supply side that we discussed yesterday. There was also a summary of the top 4 technologies: CCUS, modular reactors, hydrogen, and best. I think demand side still is the poorer cousin and needs to be brought up to that pedestal. We had the launch of the Battery 360 Alliance in the evening, and given it's not just an imperative for a cradle to cradle kind of solution. There is a lot of geopolitical aspirations also associated with recycling, recovery of materials, which will also help us in avoiding fresh dependence on virgin extraction from different source places on the earth. So I think that was the summary from yesterday, and today's session was also really great. I'll not attempt a further summary in addition to what you mentioned, Roxana, but 3 points that stood out for me is one, Dr. Karade, what you mentioned about technology transfer. You said it's not yet formalized, so how do we do that is something which struck me. Similarly, there was also a question about proof of concept and shallow domes and the local skills that are forgotten in the architectural context. So in our effort to standardize building codes, are we missing out on some of the vernacular aspects of architecture? And definitely, as in other parts of the energy transition, we say that there needs to be a regulatory sandbox to experiment with solutions. So literally in a building with a sandbox is what I would say we need to start bringing these innovative technologies in and experiment and establish those proofs of concept. So I hope I definitely learnt a lot over these last 1.5 days, and I hope you have also gained and built new connections. Look forward to staying in touch. This is not just an event-to-event kind of where we say bye today and hi in the subsequent year. Let's stay in touch. Work towards a sustainable energy transition. Thank you so much. So yeah, I think lunch is ready outside. Please join us for it. Thanks.